session is about building a seamless steel and scrap supply chain and the seamless movement of cargo. And that is not the only thing that this is, we are talking about the seamless movement of cargo. It's also how reliable that would be. And along with that, at what cost? So that cost, when we talk about the cost, freight cost becomes a very important component on that. And to focus on all these, I have 4 different perspectives. We are still waiting for Mr. Syed Abdul Rahman, so he might be on the way for his focus on the railway freight cost. Along with that, I am joined by Mr. Ankit Garg. He is head Hub and Satellite Unit, Tata Steel, bringing the perspective of regional distribution, inventory positioning, and customer delivery. I also have Ms. Deepanshi Pugalok. She is a senior research analyst at Drury, who will examine the medium and long-term freight outlook for 2027 to 2031, with particular emphasis on larger vessels. And then I have Ms. Tanvi Sharma. She is a senior research analyst at S&P Global, who will focus on trade and freight conditions during the remaining months of 2026, particularly for small and mid-sized vessels. So I have a couple of presentations, rather 3 presentations today. The first one is by Mr. Ankit Garg. He will be joining online. Mr. Garg began his career in the IT sector with TCS in 2007 after doing BTech in civil engineering. Post-MBA, he entered the natural resource and heavy industry sector, serving at Vedanta Resources and subsequently at Jindal Power Limited. In 2013, Mr. Garg joined Tata Steel as manager projects in Orissa, contributing to the company's major greenfield expansion. In 2021, he was promoted as head logistics operations, Khopoli and Hosur. And in 2026, this year, he was appointed in his current role as head hub and satellite units North. Given responsibility for distribution and customer service for North region, where he continues to drive supply chain efficiency and network optimization for the company. So Mr. Ankit Garg, he will be joining online. Can I have his presentation, please?
Hi, good morning, everyone. Good morning, all the present esteemed guests, panelists. So I request the team to please share the presentation. Until the time the presentation is being shared, so I'll just take you through the presentation that we have prepared. Majorly, yesterday we have looked at the outlook of steel industry with the industry experts, and we were able to understand how the steel industry is currently moving, and we are currently at around 180 million tons of the steel capacity, and the target is to move to 300 million tons by 2030. So there are a lot of challenges currently that we are facing. And logistics definitely is one of the challenges which is there for the future growth of the uh, steel industry. So if we are able to understand the major challenge that is there is the cost competitiveness, as Mr. Rahul has already spoken. Hope that I'm audible.
Yes, yes, you are audible. Ankit, we can hear you.
Yeah. So, were you able to listen to whatever I've said till now, or?
Yeah, you are audible. You have been audible since beginning.
Oh, great, great. So, can we come to the presentation slides, please? Great. So, if we are able to look at the data, so the steel, in steel, we are able to see that the logistics contribute to around 2,000 to 3,000 rupees per ton of the cost of, per ton of finished steel. That is what the spend is around, if we talk about the rupees per ton spend. And we are able to, see that as per the global standards, it's around 5% of at which is the global best, but in India it is around 10 to 12% of the steel delivered. So the cost is comparatively high in India, right? And the reasons are obviously, I've tried to break up the logistics cost in various heads. So freight, the primary haul, if we look at, we are, again adverse as compared to the global standards in handling and terminal charges also, as well as inventory holding also, as well as the admin and IT charges also, we are adverse. So everywhere we are able to see that we are not competitive as far as the global benchmarks are considered. So, so these costs we need to work on each and every in a global scenario. So, can you please move on to the next slide? Yeah. So, if we are able to understand the steel ecosystem, we see that there are three parallel chains that are operating independently of each other. So, one is raw material flow, one raw material chain. So, from mines, the material starts, it moves through either rail, postal, or road. It goes through a stockyard or port, and then it goes to steel plants. So this is one chain where we face a key challenge of the rail congestion, first and last mile connectivity. So in rail, definitely there have been many improvements recently. Dedicated freight corridors have come up, but still there is a congestion that is being faced in the last 100 or 150 kilometers, because the same railway line is being used by passenger rakes as well as the freight rakes. So there is a heavy congestion near the consumer, where the consumer is based. Then the second flow is of the scrap. So which is a very fragmented in a very fragmented state right now. So there are collectors. They give the scrap to traders, and then it gets processed, and then processed scraps is reaching the steel plants. So here you can specifically see the share of logistics cost and delivered cost is very high. So it's around 12 to 15%. Because of non-rakeable loads, one of the reasons is because because of the fragmentation, the load is not suitable for to be handled by rakes. So they are basically majorly moving the material through road, and that is one of the major issues. Also, the last flow, if we look at, is from the steel plants to warehouses, the distribution of steel basically. So it moves from steel plant to warehouses or stockyards, and then it goes to distributors, and then it finally reaches to the consumers or the customers. So here also we see that the delivered cost is around 8 to 10%. So which is the key challenges that we face in this chain is because of inventory holding and distribution inefficiencies. So here also there is a lot of work to be done, and network optimization is definitely one of the areas which is very important for this flow. So if we are able to see that these three chains are working independently, but if we are able to somehow integrate and create a synergy between these chains, then definitely there will be a lot of efficiencies, operational efficiencies that can be achieved, and the cost can be reduced. So this also leads to a longer turnaround time, and there is also a variability in the total overall material flow, which is also leading to a lot of cost leakages. I've tried to get across in the next slide. Can you please move to the next slide? So in the next slide, we are able to see this breakup of the cost leakages that is happening across the every movement here in our country. So if we see this entire logistics cost, it is made up of not only freight, but many other factors, many other small costs that are adding up to become this entire logistics cost. So the first, right side, the blue bar shows the net logistics cost, which is the actual logistics cost. That is around 20 to 30% of this entire 100%. But then there are many other small costs which add up to become which contribute to this total logistics cost, like inventory holding cost, port and terminal congestion, yard dwell time, empty backhauls, dead freights, multiple handling, loading and unloading, and then long haul transportation. So in India, typically if we look at our steel industry, so the industry is concentrated where the raw material is easily available, near the raw material source. And the consumers, which are based across India, they are having higher lead, high distance from the origin steel plants. So this long haul transportation cost is definitely on a higher side, because when the vehicle is moving on a long haul, there are many maintenance issues, there are other costs also involved. So this is one of the out of the entire leading factor, one of the leading factor in the country. So in India, logistics, if we look at, is majorly for steel is majorly dependent on road. 60 to 70% material is currently moving through road if we consider the last mile connectivity as well. So here we need to understand that how we are able to move the goods in a very efficient manner, so that the leakages are minimized. So if we are able to come to the next slide, please. So here in the next slide, we are able to see we have what we think that the future state will be. So current reality is road heavy, that we talked about. 60 to 70% share of steel is moving by road, and then there are rail bottlenecks, which I have told about, the last mile connectivity also, and the capacity constraints. So typically in the peak season, when we see when there is high heat, so the electricity demand that goes up to the highest possible time, and railways are forced to deploy all the rakes towards the coal supply, so that the power plants are functioning in a very streamlined manner. So that time we are facing shortages in rakes. And also as the rail network is maturing, so the number of passenger trains are increasing day by day, and the same network is being used by as passenger trains as well as the freight trains, and the preference is given to passenger trains. So there are bottlenecks currently in the rail network. And also the coastal network is underutilized currently, which is also a very underutilized resource. So if we see in coastal, there is a huge opportunity as India has got a great coastline. So there's a good opportunity that east to west movement can happen entirely by coast, and even east to south and west to south movement can happen through coastal vessels. So in future, if we need to move to 300 million tons, so these all three modes, we call them multimodal movement. So it needs to function in a very synergized way. So future state, if we look at, we think that it should be one network, one plan, seamless flows. Railway should be handling the long haul movements majorly. So the DFC's dedicated freight corridors, already two are functioning and many more are coming up. So once they are ready, so railway will be able to take up the long haul movements entirely. Port-led aggregation is also one thing which we can look at, where the coastal logistics can play a bigger role by taking up all the bulk movement, which can be moved through coastal logistics in the western and southern part of the country. And this will entirely lower the delivery cost. So it will lead to better asset utilization as well as the lower carbon footprint. As if we are looking at the carbon footprint area, road is having the highest scope 3 emissions, then the lake is a better one, and the best one is the ship. So vessel is having the lowest carbon emission per ton of steel. So if we are able to convert the movement towards the coastal portion, then definitely the sustainability part of it will be better. So if we see the entire value chain of steel, so the major focus that is there should be on the scrap ecosystem transformation, because a lot of work has been done on the bulk movements of iron ore and raw material as well as the steel bulk movements. But majorly now we need to look at the scrap value chain. So can you please go to the next slide? So in the scrap value chain, if we are able to see, currently there are a lot of issues. Majorly, as the steel production expands, scrap will become an increasingly strategic raw material for the production. So currently the scrap ecosystem is fragmented and largely informal. Collection is dispersed and the quality standards are varying and traceability is very limited. So I've tried to build in the current state what we are having currently. The visibility is poor, the logistics is inefficient because highly it is dependent on road and rakeability is less. So in future, we need to transition this into a aggregator based model where we have regional collection hubs. The collection can be on digitally enhanced e-marketplaces, so that there are small retailers, they can connect digitally and they can aggregate their material to a regional collection hub. Then definitely that regional collection hub can also function as a processing center, and then the movement can happen through rail and coastal vessels, and then the metal can reach to steel plants. So this will definitely in future, if this sort of arrangement is being reached, then this will definitely bring in more efficiencies. So regional collection hubs, if we look at one of Tata Steel's Rohtak plant, is an example of this. So these plants are now coming up across the country. So other steel manufacturers are also looking at setting up these facilities. So this is a value creation impact where we can look at annual savings of around 800 to 1200 crores. Around 5 to 7% improvement in the efficiency and around 10 to 15% reduction in the CO2 emissions. That can definitely happen if we are able to do this. But doing this will definitely require a much greater visibility across the value chain, across the supply chain. So which brings us to the next slide. In the next slide, we are able to see that by using digitalization and analytics, we will be able to provide the visibility, and the intelligence will be able to unlock efficiency, growth, and agility. So currently, we are in the scrap value chain and the entire value chain of steel there is a limited visibility. Specifically in scrap, the processes are manual, and due to which the planning is suboptimal. It is not able to, we are not able to plan very efficiently due to the lack of visibility. Data is underutilized. The data is existing with many players, but it is in silos. So the ecosystem is disconnected. So all these problems are leading to inefficiencies in the system. So for this, there are transformation levers like real-time tracking, digital control towers, predictive analysis, and logistics marketplace as well as e-marketplaces for scrap, which can definitely create end-to-end visibility across the network and can improve planning, reduce inventories, increase asset utilization, and enhance customer service. So entirely, if we see, the future supply chain will not only be a multimodal supply chain, but it will be digitally orchestrated. So this digitalization impact will definitely help us to unlock the efficiencies in the value chain and bring more cost reduction and cost savings for the companies. So, but there is a proposal that is there, and many industries are currently working on that. So coming on to the next slide, logistics parks, if we are looking at logistics parks, they can become an integration node as well as they can become a major aggregation points. So currently, if we see, they are being currently viewed as only the warehousing locations and transshipment locations. But logistics parks have a higher value that they can unlock. So their future role can become a much broader role. They can become integration nodes where rail, road, warehousing, scrap processing, as well as value-added services such as the processing centers, cutting, grading, packing, bending, all these processing centers can come in. And digital platforms can also come together so that the value chain is unlocked. So if the entire such an ecosystem is built, so definitely the scrap as well as the other material as well as the distribution material, they can be synergized and can be delivered to the end consumer as well as the steel plants. So the entire ecosystem is currently being looked at with the various logistics partners as well as the various companies who are working in logistics field. So there's a big opportunity in India. Around 30-35 such strategic locations have been identified to build these big integration nodes. Many logistics firms are working on this, and this will help in lowering the logistics cost by 15 to 25%. The fast turnaround time will become much faster and asset utilization will go up. So this is one of the levers that can definitely help in increasing the efficiency and lowering the cost. So, coming on to the conclusion, last slide, please. Next slide, please. So what we believe is the future of the supply chain is just not a better rail network or a bigger warehouse network or a larger scrap ecosystem. It's an integrated steel to scrap network, raw material value chain, logistics infrastructure, scrap value chain. They must all operate as one connected ecosystem through digital intervention. To achieve this, the industry needs to focus on integrated networks, multimodal logistics, formal scrap ecosystems, digital visibility, and sustainable logistics. So this entirely will lead to integrated and resilient supply chain, lower costs and faster turnaround times, higher asset utilization and lower carbon footprint and sustainable growth. So these are these will be, I believe, will be the 5 priorities for the future: integrated networks, multimodal logistics, formal scrap ecosystem, digital visibility, and sustainable logistics. So this is what I believe the future will be, and it will definitely help India's competitiveness to increase, and it will determine how efficiently we move material, information, and carbon across the value chain. So with this, I conclude my presentation. Thanks, everyone. Thank you so much.
Thank you, Ankit. Thanks for this, high research on high inland logistic cost and also on cost leakage and integration between road, rail, and coastal shipping for domestic movement of cargo, all these. Now we go to the next presentation, which is on the freight side of long and medium term outlook. So it will be Dipanshi Pugalok. She is a senior research analyst at Drury, specializing in dry bulk shipping markets. Her work focuses on analyzing global supply and demand dynamics and the impact of macroeconomic and geopolitical developments on seaborne trade and shipping rates. With a background in economics from Delhi School of Economics, she combines data-driven research to provide insights on freight market and shipping outlook. Dipanshi.
Thank you, Rahul, for introducing. So I'm Dipanshi, and I mostly look after the dry bulk shipping at Drury. And today, today I'll be integrating the logistic part in the steel supply chain. So starting with my presentation. Next slide. Yes. So, starting with, like, how does shipping come into the picture of the steel supply chain? I think the screen is, yeah, thank you. So, I would like to mention that with the movement layer that comes in picture is that the steel reaches the end user from a process, and the process starts with the mining of iron ore and the coal. And then that iron ore and coal is moved through the different transportations, including the shipping, the railways, and the roads. So shipping comes in picture from there. Can I just mention that the screen is blinking too much, so I'm not able to focus? So, as I was mentioning that a ton of steel doesn't begin at the steel plant, it undergoes a process. So the process starts with the mining of the raw materials that includes mining of iron ore and coking coal, and that moves through transportation, the deep sea, and by railways, by road, and by the coastal shipping. So the freight comes in picture from there, because when we are talking about the prices of the coal and the iron ore that is used for the steel making, the prices is decided due to the freight cost. So freight cost is a very major component on the prices. So if iron ore is getting mined in a country and it is going to another country, it has taking a long process, and it is accompanying a lot of freight in that. So the iron ore and coal reaches the importing country and the steel producing country, and by different methods that we know, that by the blast furnace we use iron ore and coking coal to produce steel. So it gets processed, and then it moves to the distribution end of the construction and infrastructure. And at the end, again, when that steel is scrapped, it is again converted into steel using the electric arc furnace method. So this is the whole life cycle, I would say, of the steel, that how it is processed and how logistics and the freight comes into picture. So moving on to the next slide. So I assume that most of in the audience might not be from the shipping background and might not be aware of the shipping terms that I'll be using today. So just for the introduction, when we are talking about ships, it's just might be a ship for everyone else, but when I talk from my perspective and from a shipping company perspective, we have different kinds of ships. So today we'll be mostly talking about the dry bulk ships or the dry bulk carriers, but I have tried to put out all the types of ships that are available in the and that trades in the market. So including the dry bulk, the oil tankers that carries the crude oil and the petrol, jet fuel, etc. We have LNG carrier and LPG carriers, and then we have chemical tankers that carries all the methanol and different kind of caustic soda, etc. And we have containers, so all the goods that are packed in a parcel, we get in containers. So what do we carry in majorly in dry bulk? So that is iron ore is the most traded commodity in the dry bulk market, and then it is coal, including both thermal coal and the coking coal that is used for steel making, and we have another smaller commodities including grains and fertilizers. And why do we are even talking about these commodities when it is a steel conference? So the freight for the whole market is majorly decided by the iron ore and coal trade. So, and when we are talking about the steel and steel products, they are mostly carried in the smaller vessel segments of dry bulk. So, even though they are not directly impacted, but due to the freight that is there in the upper segments that carries the iron ore and coking coal, they have an impact on the smaller segment as well. So I would say the larger segment that carries the iron ore and coal is the deciding factor for the smaller segment that carries the steel and scraps. So that is why it is important to even understand that why these commodities are important. So moving on. I have tried to put down all the commodities that is there in the dry bulk and that we cover. So we have iron ore with the largest share. Then we have coal bifurcated into coking and steam coal. Then we have all the grain and agri-bulk commodities and other smaller commodities including the steel products, the article of steels, soybean, bauxite, and all those smaller commodities. So also, moving forward, I'll be using a lot of terms that are related to shipping and different type of carriers. So I have just tried to put down what kind of carriers are there in the dry bulk. So starting from the smaller segment, that is the handy size segment. So it is the segment in which most of the steel products and the steel scrap is carried. So that is around 10,000 tons of cargo to 40,000 tons of cargo. Then we have the second segment, that is the Supramax segment. 40,000 to 70,000 tons of cargo is carried in this segment. And most of the commodities that is traded is coal, the scraps, and the grains. And similarly, when we talk about Panamaxes, it's the similar kind of commodities, the coal, grains, iron ore, pet coke. And in the largest segments, the most traded commodities, iron ore, coal, and bauxite. So that is what I was saying, that when we are talking about the bauxite, even though it is the largest segment, the cost of, I would say, per ton is lower in the largest segment, but still a lot of commodities that are traded in the smaller segments, the price decider is the Cape size segment. So anything that is trading in handy size and Supramax, it is the price taker from the Cape size and the Panamax market because it controls the market. So this is why I wanted to put it right here to understand that how it is important for the steel market. Moving forward, I would like to present the long-term outlook for like what we are expecting, that how iron ore market will be and how coal trade would look like for the next 5-7 years. So even though iron ore is the largest traded commodity, it has almost reached to its peak of production. So the mining depends on its how much the capacity the company has to process that mining. So the major companies that mine the iron ore are almost on their I would say full capacity. They are producing they are mining the iron ore. So that is why mostly the outlook looks very stable, and even you can see that it has not increased much in the last 5 years as well. So for the next 5-6 years, we assume that it will grow, but it will grow at a very reasonable, or I would say stable pace. So that is for the iron ore, and most of the iron ore, as we are aware, that comes into China and comes from Australia and Brazil. So, and similarly, when we talk about coal trade has become a little stagnant, and it will also remain stagnant for the next 5-6 years, and it will keep decreasing because of the reason that all the decarbonization and environmental regulations that are getting stricter with the time. So that drives the coal outlook. And yes, so when we talk specifically about India, so India used to be a major exporter of the iron ore. If I see in 2010 that if I take the share of both exports and imports, India used to export almost 99%, and there was only 1% of import in the total trade of iron ore. But the situation has been changing in the current years. We have seen a trend developing that India is, even though it is exporting, but it has also starting importing some of the iron ore. And the reason being is that Indian iron ore is not the quality issues, I would say. So the iron ore that India imports is of the higher quality. And if I talk in particularly in technical terms, so we have the Fe content in iron ore. So India imports the 62% or 65% of iron ore so that it can process, because there were a lot of fumes and the particles that were not able to process in iron ore. So India started pelletizing the iron ore and then started using. So for that, India was using its own iron ore, but now it is also importing some of the iron ore. So you can see that year to date in this year, India has, in the total trade, 25% is imports and 75% is exports. And why is this happening? So if I see the steel production is on a continuous rising trend for India. And that is why on that trajectory also, the iron ore imports are also increasing. So they are following in tandem. That will the increasing steel production, we are seeing the increase in the iron ore imports, because India also needs some of the, I would say, high-grade iron ore that comes mostly from Australia and Brazil. And we are also seeing an emerging player, that is Guinea. So Guinea has ramped up its production in the last 1 year, and it might start producing to its full potential, that is around 120 million tons of iron ore by 2030. So, but that will mostly go to China, and some of it might come to India, but that is still a gray area, and we are not much have knowledge about that, but we'll see as it goes. And similarly, if I talk about that, how the prices are affecting the, as I was talking that in the price, the freight is a very major component. So if any commodity, suppose iron ore is, Australia is exporting, so we take the FOB price, that is the free on board price, and when it is getting traded and when it reaches any country, say China, so the price is now CIF, that includes the freight. So the freight components gets added into the prices, and when the freight component gets added, the prices increase in the importing country, and that also drives the demand supply of the commodity. So we are seeing that there is a continuous decline in the iron ore prices, and when there is a decline in the prices, naturally in economics, the demand rises. So with the continuous decline in prices, we are seeing the increase in imports. And okay. So as I mentioned in the starting that I'll be talking a lot about the vessel segments. So here you see that I have tried to put down that on which vessel segments these commodities are traded. So iron ore is mostly traded in Cape-size vessels, that is the larger vessel segments. And the larger vessel segments have restrictions related to like the port restrictions, because they take much larger area and there are a lot of draft issues that happens. So, but earlier it was, you can see it was Supramax, the smaller segments, but now the trend is shifting towards the Panamaxes, which which also points out that the port conditions and the draft conditions are improving for India, that we are able to handle most of it in the larger vessel segment, hence reducing the per ton cost. Yes. So when we talk about freight, we have talked about demand, and when we are talking about freight, we know that it is the demand-supply balance that decide the freight or the cost of any commodity or the prices. So we have talked about demand, but when we talk about the supply of ships, so there are 2-3 factors that we consider. The first factor is how many vessels or how many ships are going to deliver in the next 5 years, say. And there are also demolitions, that how many vessels are going to get scrapped in next 5 years, and that decide the total supply or the total how many ships will be there in the market. So I have tried to put down the outlook for deliveries and demolitions. So the deliveries are decided by that how it takes almost 2 years to for one vessel to get delivered when it's get ordered. So if it is getting ordered in 2024, it will be delivered in 2026. So we are able to map out the total deliveries forecast for a certain period. So as I speak, the 2025 was not a good year for the ordering. If I specifically talk about our market, so that is why that there is less deliveries in 2027, though order picked up in the end of the year, and that was majorly because of Trump's tariff. And this year is also the same because of all the geopolitical things that is happening with Iran, Israel. We are seeing that owners are being cautious of ordering, and they are trying to order less as till the time they can. So there might be less deliveries in the after 2029, but there is a peak of deliveries in 2028 because we have seen that the orders picked up in 2025, so that will get delivered in 2028. So that decides the deliveries of the vessel. And when we talk about demolitions, so for the past 5 years, we are seeing majorly after COVID that there has been, I would say, the below average demolitions for all the sectors. And that is because that there was very increased freight rates, which were giving owners edge to keep their vessels and not demolish them. But since the regulations and different kind of environmental regulations, just like the EU ETS and all the CI regulations that will come in picture fully by 2030, that will force the vessels to get demolished, which are not following all these regulations. So we'll be seeing an uptrend in the demolitions, and with the lower deliveries that will be there in the last 3 years of our forecast, and with increase in demolitions, we believe that there will be less fleet supply or less ships available to carry the same amount of cargo, which will lead to the decline in our charter rates or the time charter rates that is there for the trading of the vessel. So I have tried to map down our utilization. So utilization is just the supply-demand balance. And with the supply-demand balance, I have mapped our demand and supply as well. So as you can see, that utilization is going down for the forecast period, and that will drive our lower charter rates in the longer term and in the medium term. So if I talk about next year, we believe that the market will be good. So that comes and that stems from this year as well, because the Iran-Israel war might not be good for any other sector, but it has proved to be good for the ship owners because they are receiving very high charter rates. And we usually experience that in the first quarter of the year, we experience a lower market and a very stagnant market, but that has not happened this year because of the increase in, firstly because of the trade that was up for the major commodities like the iron ore and bauxite, and also because there was a lot of, I would say, potential for trade in the longer haul. So when the Strait of Hormuz got closed, owners started shifting to longer haul trades, and also started rerouting through Cape of Good Hope. So that increases the demand and that increases the shipping distances, and in hindsight increase the demand for the ships. So that has led to increase in our charter rates. And I've also tried to map down the vessel speed. So if I talk about the smaller vessel segments, the speed has reduced for the smaller vessel segments. That is because that the bunker prices that is used in the ships has shooted up massively in March, or I would say in the March-April month. So that gave an, I would say that forced owners to lower their speed so that they can use less bunker to cover the same amount, though it might have taken them more days to cover the same distance, but the slow steaming or the slower speed helps them to save some fuel cost. So that trend has been noticeable in the smaller vessel segments, and that is not there in the larger vessel segments. I would prove that from the next slide. So I have put in the freight rates or the spot rates that is there in the one voyage for Capesize, that is on Brazil-China route for iron ore. So as you can see that the freight rate has been on a continuous uptrend, and even though the bunker cost has increased to almost 80% of the total freight cost because of the extreme rise in the bunker prices, still the owners operating on these routes had the edge because they were getting higher revenues. So the Capesize segment didn't face that slow steaming because owners were able to make the profits even when they were trading at the higher speed. So that is why we are seeing that. And at last, as I mentioned, that what is our freight outlook? So we assume that for the next year, the market will be good, the freight rates will be high from the demand-supply balance and from the market fundamentals, that there will be less effective supply or similar amount of demand that will keep the charter rates higher. But as we move to the longer term, there will be more effective supply available with the more deliveries, and the demand will remain kind of stagnant for the major commodities, and that will decrease our charter rates for the longer run. So that is it about me. Thank you.
Thank you, Dipanshi, for showing your research on how the freight costs will increase for shipping raw materials like iron ore and coal, and how will this impact the steel traders as well. Now moving to the short-term period in 2026, what will happen? We have Tanvi Sharma. She is a commodity research analyst in the Commodities at Sea. She follows the pulse of the dry bulk market from commodity trade flows to freight trends. Her work combines hands-on market exposure with forward-looking research and forecasting expertise. A postgraduate in economics from JNU, she has prior experience across dry bulk trade and freight market research and has contributed to industry discussions at several conferences. Tanvi? You.
Thank you, Rahul. Thank you for the introduction. Let me just check. Okay, this is working fine. Okay, so my name is Tanvi Sharma, and I'm from the Commodities at Sea team from S&P Global, particularly from the Energy division. At Commodities at Sea, we basically track dry bulk shipments for all dry bulk commodities that are shipped on dry bulk vessels. Particularly for today, I will be covering the following. My objective will be to connect what disruptions are happening in the global shipping industry with the larger impact on steel markets, particularly for India. And the agenda is as follows. I will begin with talking about what have been the volume trends for steel product trade, some of the major trade corridors, key export and import partners, some of the major shipping routes and choke points, and this becomes critical nowadays that the Strait of Hormuz crisis is still ongoing. I will talk about the shipping capacity that is specifically available in the Persian Gulf and how that misalignment is kind of shaping the freight industry or the freight trends in the global shipping industry. And I will end with the freight and commodity outlook. Okay, so to begin with, I would like to mention that a lot of steel that is traded internationally, it might be containerized or as well as it might go on bulkers. So what I will be presenting here is just the volume that moves on bulkers. That proportion varies depending on various countries. For India also, it has kind of fluctuated over the years. But I'll begin by talking about the export and import trends. So in the first chart, as you can see, broadly, India has exported a lot of steel as well as it is dependent on a lot of semi-finished steel imports as well as to some extent earlier finished steel as well. But earlier it was a net exporter of steel. If you focus on the red line, that was kind of positive for major part of the period that we saw earlier, but it has narrowed for last couple of years. And in 2026, we noted that in the period between January and June, India exported around 3.8 million metric tons of steel, but it imported 4.5 million metric tons of steel, turning India into a net steel importer. On the right side that you see, we have steel arrivals, which are basically steel imports for India, as well as the scrap imports. The scrap that is coming into India, it might be containerized and it might come on bulkers as well. A lot of high value scrap is mostly containerized, but that volume, that proportion that comes on bulkers versus containers, that also fluctuates depending on freight rates. And this is where, freight rates become really important in deciding factor for what will be the volume trends that come and on which kind of vessels. Like if you notice, a lot of break bulk cargoes, it's not just true for steel, it is true for many break bulk cargoes, but specifically focusing on steel, you notice that in 2022, the volume of scrap that was coming on bulkers, that sort of increased much more as compared to what we had seen in the previous years. And that was because in the post-COVID time, we had seen a spike in the container freight rates. And hence, it made much more sense for a lot of volume to shift to bulk vessels. That again sort of came down in the next 2 years and as container rates also normalized. This year as well, because of the geopolitical crisis, we've seen the freight rate spike in most of the segments. It's not just true for containers or LNG, LPG, of course, but also there has been a significant impact on bulkers, and hence, again, that volume that is coming, the scrap volume that is coming on bulkers has reduced this year. Can you move the slide back? Yeah, thank you. I think this is not working properly. Can you go back to the beginning and I'll direct you when to move to the next slide? Yeah. Okay, so now can you move to the first slide and begin? We've jumped a few slides in between. Yeah. The one before this, yes. Thank you. Okay. Now I'll be focusing on which are the key export-import partners for India and why does it really matter and what is the key takeaway. So if you focus on the first chart, this is capturing the trade volume of steel on bulkers for the period between January and June. Now, of course, Europe and Middle East are major export partners for India. I think roughly 50% of steel that is being exported on bulkers is moving to the European countries. That volume has come down this year. Multiple reasons are there. Partly it is because of CBAM. partly it is also because of various kind of regulations that Europe is coming out in terms of tariffs and duties and so on. Our other major market is Middle East, which again is disrupted because of the reasons we all know. A lot of cargoes from India have now been diverted to Southeast Asia, Vietnam being the largest trade partner in the period so far in the year. A lot of these vessel diversions that are moving towards, say, Pacific instead of the Atlantic, that really is important from the shipping perspective because it sort of realigns the demand and supply balances, the regional demand and supply balances, and hence the freight costs that you pay. So moving to the import side, our export markets are kind of squeezed at one end, previous slide itself. Yeah, our export markets are squeezed, but if we focus on the imports, we have increased our imports by more than 1 million tons just from China. And of course, this has happened in the past. Whenever there is excess supply in the market, China diverts a lot of its cargoes to other regions. But in the crisis that we've seen so far in the year, most of the vessels that were earlier going to the Middle East, and we could evidently see this while tracking like each individual vessels on our vessel tracking platform, we could see that all the vessels that were earlier going to the Middle East, when the crisis sort of escalated, they anchored there, they were looking for buyers, and then they really turned around and moved to India. This happened not just in March, but this trend kind of continued in the months to follow because China started exporting much more to India. Of course, it's exporting to other regions as well, like Southeast Asia. But that year-on-year increase that we saw for Chinese exports, India was like the major absorber of that volume. And this has not happened with any other import partner. It is majorly Chinese steel that has come into India so far in the year. Next slide, please. Okay, so we've talked about exports as well as imports. Now, why does it become important in shipping? Because in the first chart, if you notice, since our major markets for steel exports are Europe, Middle East, and so on, a lot of steel that goes from India has to go through either the Red Sea or the Strait of Hormuz, basically the Middle East area. And that is extremely prone to geopolitical crisis. So it's not just 2026. If you look at major choke points that we look from the shipping perspective, whether it's the Panama Canal, Suez Canal, the Cape of Good Hope, and so on, we look at the transits and the proportion shifting over the years. It first started in 2024 when there were a lot of attacks in the Red Sea. A lot of vessels that were previously passing through the Red Sea had to divert through the Cape of Good Hope. And why does it really matter? Because it's the same supply of ships that is available globally that is undertaking a much larger voyage, much longer voyage, and hence the time it is being employed in one voyage increases and like goes off through the roof. Like compare just the Red Sea area with the Cape of Good Hope around Africa. That laden duration for which that a vessel undergoes, that increases, and hence it squeezes the supply that is available in the market, which is like Economics 101, the freight rate spike. So it was not just for a short period that it happened in 2024. That impact that the attacks in the Red Sea created were pretty long lasting because commercial shipping kind of works that way. It gets impacted for the longer period. And since like 2024 and 2025 as well, we can see most of the vessels are still like moving around the Cape of Good Hope and not passing through the Suez Canal. That just elevates your base freight cost in general, which is not easy to bring down just because situation kind of normalizes over the period. It is only gradually that normalization comes. Now, what happened in 2026? Again, we do have a lot of vessels still transiting through the Cape of Good Hope, but also that realignment is even more necessary now because that lopsided supply that was there in that region, that has exacerbated because even the Strait of Hormuz got impacted and not just the Red Sea or the, moving around the Cape of Good Hope. If you look at the import side, in the other two charts, we are not that much exposed to any of these choke points because mostly we are like importing from China or most of the imports that are coming from already like other routes and not through like the Suez Canal or the Red Sea. So in that sense, we are relatively less exposed from the import front, particularly talking about scrap imports and not just steel, scrap imports and not just steel imports in general. In the last chart, we can see we still are relatively more exposed to Suez Canal because a lot of scrap is coming from European countries, Bahrain. Okay, the ones coming from Brazil are still safe, but relatively more exposure for scrap imports. Next slide, please. Yeah, so again, why does this become important? Because any kind of geopolitical crisis in any part of the world will disturb the demand and supply balance in that region, which will inevitably impact the freight cost in other parts of the world. So the next slide. Here I will just walk you through with what's really happening in the Strait of Hormuz. And again, we'll connect the dots and why does it become important for freight. So if we look at the weekly transits of dry bulk vessels through the Strait of Hormuz, means like going in and coming out, that average weekly transit of like 30 dropped to just 3 to 4 vessels after the war escalated in March. With the MOUs that was recently signed, there was like a short-term respite. Just for one day, that number spiked to 23 just after the MOU was signed. But again, it kind of gradually, it came down. And this is not just true for dry bulk. It has also been seen for other kind of vessels, whether it's LPG. Containers are still, it's a very depressed story there. But even with the case of LPG and LNG, that number of transits still have moderated after like this signing of the MOU. It has come down again, and the situation still remains uncertain. If we look at kind of a leading indicator that we look at, what's the fresh volume of loadings that is taking place, the incremental loadings, that also remains subdued. So the situation is still kind of uncertain. Why this becomes important and how we look at this to really project what can happen is something I will mention in the next slide. Yep. So, okay, in the next couple of slides, we'll look at what is the fleet capacity in that region. Now, again, the demand side of the demand story is very important in general, but what really moves the rates in the short term is how much of tonnage or the vessel supply is really available in that area. So if we look at Middle East in general, which is, we are looking at 3 different regions, the Persian Gulf, the Strait of Hormuz, and the Gulf of Oman, meaning the Strait of Hormuz and the west and east of that strait. The supply, the vessel supply that is available in that region is significantly lower compared to last year. If we look at the line in blue, or the teal colored line, that is significantly low compared to last year. Seasonally lower, year on year lower, and actually has reached close to the 5-year average that we have. Next slide. If we look at just the Persian Gulf, so a lot of trade in the Middle East is also intra-regional trade. We also need to look at whether any supply is available within that area that can come out swiftly as and when the situation normalizes. If we just look at that volume towards the west of the Strait of Hormuz, that volume is starkly low. For this season, it is below even the range that we've seen for the last 5 years during this season. What does it really mean? Like, even if another MOU is signed, even if the sentiments get improved, But can the rates come down immediately? The rates can only come down immediately when the vessels are either coming out of the strait or passing through the strait, which means more supply or more tonnage is available to cater to that demand. Unless and until that alignment comes about, freight rate normalization isn't technically possible immediately. Gradually, yes, but so as long as this misalignment in supply is there, like immediate hopes of normalization are very bleak. Next slide, please. So we saw the supply in Persian Gulf itself is quite low. Now we look at whether supply can come from outside and move into that area. So for that, we look at the vessel movement patterns, which is the area or which are the countries or the regions which supply that tonnage to Middle East. When we look at that for different kinds of vessels, Panamaxes, Supramaxes, Handysizes, we see that Indian subcontinent in general plays an important role because it's a major tonnage provider to the Middle East. What does that mean in very simple terms? A lot of vessels that would probably load or discharge in the Indian subcontinent area that would move back to the Middle East. And hence, it becomes inevitable to see whether that supply is available in that Indian subcontinent to quickly or swiftly move to that, pass through the Strait of Hormuz to bring that lopsided supply down. Next slide, please. So that supply in the Indian subcontinent that I mentioned, if we look at that, it is not the case that any excess supply is currently available. In other words, it is not the case that just because there was a crisis in Middle East, that a lot of vessels that would, in one case, have gone to the Middle East that are lying idle in the Indian subcontinent area. No, that's not the case. They are obviously employed elsewhere now. So there's no excess capacity that is at the moment available in this region, which can swiftly move to the Strait of Hormuz or the Persian Gulf to load more cargoes from there. Hence, we looked at the supply both within the Persian Gulf and outside the Persian Gulf. We are not seeing any indications that rates can normalize immediately. Next slide, please. Okay, I will move to the dry bulk outlook now. First, I will talk about the outlook that we have for all the commodities in general, and then move to the freight outlook. Next slide. Okay, so as was mentioned earlier also, because of the geopolitical crisis, shipping industry always tends to benefit, ship owners in particular, because freight rates spike because of congestion, vessel movement disruptions, and so on. If we look at commodities, there is organic growth in commodities that was already happening, but there are also some impacts that we see because of the crisis itself. So in some commodity cases, like there are first order effects like fertilizers. A lot of fertilizer that was coming from the Middle East that obviously got disrupted. So our outlook has actually kind of reduced for the fertilizers. And this chart only talks about the outlook for the third quarter of this year. So obviously the first order effects are fertilizer supply is disrupted. Minor bulk is partly impacted because a lot of building materials, particularly limestone, would flow out of UAE, which again is not coming. And India is again suffering because of that. India was the major limestone importer from UAE. So those are like the negative impacts. But on the upside, there have been some second order effects or indirect effects. Energy prices, as we all know, had gone off the roof when the crisis started. And a lot of countries switched to cheaper alternatives, which is coal. So even regions like JKT, we look at Japan, Korea, Taiwan as a region together, that is not very much dependent on coal, but on gas. They started importing a lot of coal in the second quarter. So our outlook for coal actually improved. Similarly, for agri-bulk, we have the expectation of El Nino that would really play out during this year. Same slide, please. Previous one. there are sort of negative impacts on building materials and fertilizers, but at the same time, there are positive impacts on coal that we are experiencing. So in general, our third quarter outlook has actually improved. We're expecting roughly 1.6% growth year on year for the entire dry bulk sector. And this has improved than what we were expecting in early part of this year. Like if we compare our February outlook with the January outlook, the increase has been close to like 1 percentage point in our expectations. If we look at 2026 outlook as a whole, we're expecting a 2.5% increase year on year, again, which is much larger compared to what we were expecting in the beginning of the year. Next slide. Yep. So in terms of freight outlook, I will be focusing on Supramax and handy size vessels. As was also mentioned earlier, we have different types of vessels which ship different kinds of commodities. Some commodities are concentrated, like iron ore mostly goes in Capesizes, and a bunch of like 2-3 commodities would go in Panamaxes, but Supramax and handy sizes, which are the smaller segments, they carry a bunch of commodities. So the freight outlook for these will not just be dependent on 1 or 2 commodities, it's a bunch of commodities together that will really drive the Supramax and handy size outlook. And of course, it is also linked to other vessel types, Capesizes and Panamaxes, but here I'll be focusing on what's the key driver just for Supramax segment. So demand as a whole, for Supramax, 50% of the demand is actually driven by just the minor bulk segment. And by minor bulk, I mean that would be including building materials, steel products, forest products, a lot of metal ores, all of that would be going on within minor bulk on Supramaxes. So that for the year, we have a positive outlook, but agri-bulk outlook is kind of stagnant because we have the El Nino coming up. So agri-bulk trade will have like it will have a subdued impact on agri-bulk shipments in general. So overall, Supramax demand is expected to increase very modestly by roughly 1.3% year on year. But again, the next thing that really comes into play is what's the vessel supply or vessel duration and employability of a vessel. And here, congestion plays an important role. So Supramax, which is a geared segment, we've seen very elevated levels of congestion so far in the year, which is also expected to persist going forward. If you look at the chart on the right top, which is the laden ballast duration that we look at, it just simply means the time that a vessel is taking to complete a voyage, the time for which it is laden. If there's a longer distance involved, like more transits through the Cape of Good Hope, for example, it will be a longer distance, and hence that utilization of that vessel segment will increase, which will squeeze the supply and hence increase the freight rate. So in general, if we look at that laden duration, that has increased so far in the year and it's still expected to go up, which is what will pull up the freight rates for 2026. If you look at the last chart, we expect roughly an increase of $3,500 per day for the S11TC average. This just means it's a benchmark that we look at in shipping parlance. It's a benchmark where we track 11 major routes for Supramaxes. And if we look at the rates for, like at the quarterly level, it has already spiked a lot in the second quarter of this year because of congestion, trade, geopolitical crisis, actual blockade of vessel movements in the Strait of Hormuz and so on. There was roughly a $7,000 per day increase that we saw in second quarter. That is expected to moderate a bit in the third quarter because there are expectations that congestion levels will moderate compared to the second quarter with the crisis in the Middle East gradually easing out. So that moderation is expected, but compared to the third quarter of last year, the rates are still expected to be up by roughly $2,000 per day. Next slide. We have a similar outlook for handy sizes as well. So broadly, demand is expected to be stable because For a lot of commodities like minor bulk, yes, there are upsides to it, but coal, despite having a softer landing as compared to what our expectations were in early part of the year, still overall the yearly volume is expected to be kind of stable and not go up. So they will balance out each other, and hence the overall demand for the handy size segment is expected to be stable. But again, because of congestion and longer distances, the laden barrels duration is increasing, which is what is pulling up the utilization and hence the freight rates. So again, an increase in 2026 for handy sizes, as well as in the third quarter, because even though congestion did play an important role in spiking the rates in the second quarter, it wasn't as acute as what we had in Supramaxes. So we are not expecting that moderation, like quarter-on-quarter moderation, like we had for Supramaxes. In the third quarter, rates are still expected to go up. And overall for the year, we have roughly an expectation of $14,000, $14,200 per day. Yeah. So overall, a lot depends on how the crisis in the Middle East eases out, how swiftly the supply becomes more aligned, and how the congestion picture really moves up in this region, and hence how much the rates become like ease out for all of these 11 major routes for Supramaxes and 7 major routes for handy sizes. Yep. Thank you.
Thank you, Tanvi. For the paucity of time, we might not take up questions from the audience, but I encourage everybody to please drop emails if you have any query to any of the panelists, and we will try to respond it soon. Thank you.
Thank you, Rahul, Tanvi, and Dipanshi. May I please now request Rahul to hand over the token of appreciation to both the speakers. Can we have the token of appreciation? Yeah, Dipanshi, you can go first. And a photograph as well. And my sincere appreciation for both the presenters. Now may I please request Mr. Dipankar Mukherjee, Chief of Marketing, M Junction, to come onto the stage and hand over the token of appreciation to Rahul. And a group photo as well, Dipti. Tanvi and Dipanshi, you can also join, please, for the group photo. And also a very big thank you to Ankit. If if you are hearing us, thank you so much for presenting your views virtually. Thank you. So, ladies and gentlemen, we move to the next session, but before that, we have few very interesting questions that my colleague Abhishek will be asking you. These are fun questions related to steel. For those of you who were not present yesterday, it was very well received by the audience, and if the answer is correct, you may stand a chance to win certain exciting gifts. Abhishek is pumping and charging. Over to you, Abhishek.
Thank you so much, Amit. And good afternoon, everyone. Can I have a louder good afternoon from everyone? Thank you. Thank you so much. Before I start, I think I'm going to need the ticker. Amit bhai, is there the ticker here with you? Yes, I need that. And yes, we have quiz number 3, the first quiz of the day. So let's move ahead. Okay, before we go to the main 3 questions of the day, a quick trivia. The sale of the forgotten Air India Boeing, the number is given, in Kolkata was conducted by my organization, M Junction Services Limited. The 43-year-old aircraft was sold as a trainer for Bangalore Airport and was transported all the way via road from Kolkata Airport to Bangalore. Now, we all know that iron and steel are very heavy things, and a plane is mainly made of duralumin. So the question, ladies and gentlemen, is how much of an aircraft does iron and steel actually account for? You have to give me a percentage range, and the one who gets close to it will get the award. Let the bidding start. Yes. Sir. 95% iron and steel. Sir, plane to gir jayega. It's less. Sir. 11 to 13. I'll keep you on hold. 10 to 12. 7 to 8. 8%. 10 to 12%. 5 to 10. 20%. Too much, ma'am. 6%. No, sir. बहुत ज़्यादा हो गया, sir. Absolutely 9. 8%. Ma'am. Yes, ma'am. ज़्यादा कम हो गया. Ma'am, sir. 11. Okay. Chalo. So the bidding is done. Now I have a very, very interesting views for all of you. No one gave me the exact one, but someone said something. It's 7 to 13%. So I think sir out there said 13. 11 to 13. And anyone say 7? He said 9. You are taking the average. That's a good one. 13. Anyone? You said 8. Did anyone say 7? Okay. As you know, the Quizmaster's decision is final. I'm going to give the award to a person who said one digit at least correct, and that is sir. Sir, can I have your name, please?
Sarvajit from Tata Tubes.
So, can we have the award for sir? Thank you. Thank you, sir. Congratulations. And ladies and gentlemen, he's the first person who gave at least one number correct. Can we have a bigger round of applause for sir? Great, 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 great. Chalo. Now, the topic of the day. Yesterday we had... It's a range. I said it's a range. 7 to 13. 13. He said 11 to 13, so 13. He's the first person who gave one A correct. That's why. That's why I kept him on hold. Okay, so ladies and gentlemen, yesterday we had steel reality, steel fiction. Today we have steel others. Steel and literature. According to Roman mythology, it is said that the god of love, Cupid, uses 2 types of arrows. X-tipped for falling in love, lead-tipped for causing heartbreak. Oh my God. However, However, the idea of having a third type of arrow, which is steel-tipped, came from a 15th century Scottish poem, The King is Square, which acted as an expansion of this myth and stated that the steel arrow was used for causing a love wound that never heals. Quite painful. So, ladies and gentlemen, my question is, what is X? Ma'am. Gold. Sure. Ek bar mein. Big round of applause for ma'am. It's gold. Ma'am, your name, please. Sneha. One gift for Sneha, ma'am. Okay, so it is gold. Sorry, think steel is not used for falling in love, but kya kare? That's how the mythology goes. Okay, second one, steel and business. The X type of steel is a common tool steel that is supplied as a centerless ground round bar with tolerances similar to that of a drill bit. The name comes from a highly polished appearance of the rods, but unfortunately there is no X in that alloy. Apart from gold, steel and X are very commonly used metals. Which metal are we talking about? Chrome and manganese. No. Ma'am, you want to say something? No. Sir? Yes, sir. Bronze. Huh? Tungsten. Who said silver? You said silver. How did you tumble onto silver, sir? That's a common thing. Common thing. Apart from gold. As I said, the hardest questions have the easiest answers. Big round of applause for sir. It's silver. Silver steel. Sir. Thank you. So, ladies and gentlemen, gold, silver. Last question of this round before we go to the connect. Again, steel and mythology. There are different opinions about the material of Thor's hammer Mjolnir. Now, as per Marvel, it is forged from a fictional magical Asgardian metal called Uru. It was crafted inside the heart of a dying star. All of you will remember Anthony Hopkins' dialogue from the film. But as per Norse mythology, the original legends say that the hammer was forged from which well-known metal? Kindly raise your hands. Copper. Thoda sa brittle ho jayega, sir. Aluminium. Come on, let the games begin. Steel. Steel. Okay, sir, no problem. But the actual answer I was looking for is iron. And sir said that. So big round of applause for sir. Well done, sir. So Mr. S.K. Srivastav. Yes, and he got it. Thank you, sir. Thank you for that wonderful answer. So, ladies and gentlemen, we have gold, we have silver, we have iron. Now, let's make a connect. This nation's most valuable export is iron ore, which accounts for over half of the world's seaborne iron ore trade. It also ranks as one of the top gold-producing nations and is home to the massive super pit. Silver is also mined here as a co-product alongside gold, lead, zinc, copper. Which country are we talking about? Off in a flash, I didn't have to say anything. Australia it is. Well done, sir. Well done. Zor se tali ho jaye. Yeah, it's an easy quiz. Sir. Thank you so much. So Australia is the final answer of the steel quiz for the Indian Steel Markets Conference. This is your quiz master Abhishek saying bye-bye. Hope you all liked it. Take care. Bye.
Thank you, Abhishek. That was really amazing and wonderful to know that you know so much, not only in steel, but about other things as well. Ladies and gentlemen, let's move to the concluding session. And the topic of this session is building a value chain for decarbonization, beneficiation, raw material security, and transparent mineral markets. Some of the topics that would be discussed threadbare in this session are waste valorization and decarbonization, center plant process optimization for sustainable revert recycling and operational excellence, iron ore availability, logistical, regulatory constraints, price volatility, auction dynamics, quality differentials, and beneficiation needs, ferroalloys, role in steel quality and specialty grades, supply-demand dynamics, power costs, export markets and competitiveness, mineral exchange, improving price discovery, transparency, contract standardization and quality benchmarks. To take you through to this session, I would like to invite Mr. Arunava Mandal as the session moderator. He is the General Manager, RA and Assisted Sourcing, M Junction. Can we have a round of applause for Mr. Arunava Mandal, please? While he's coming to the stage, let me give you a brief introduction of Mr. Arunava Mandal. Mr. Arunava Mandal is the General Manager and Business Unit Head at M Junction with over 30 years of experience in business development, digital commerce, strategic sourcing, and marketplace businesses. He is a regular speaker at industry forums and has served on the Ministry of Steel's Committee on Met Coal Procurement. Over to you, Mr. Arunava.
Thank you, Amit, for the introduction and welcoming me to the session. So, good afternoon, ladies and gentlemen. Welcome to the final session of ISMC 2026. It's a, rain-filled Delhi, I would say. So everywhere you are must be getting reports about waterlogging and all. However, the one positive side that I would like to point out, that it has given Delhi a breath of fresh air. The AQI is at 61. So with this positive note, I would like to welcome you all once again to the final session. And as we wrap up this steelathon, we turn our focus to the very foundation of India's steel future, securing a sustainable, transparent, and resilient raw material value chain. Today, our industry stands at a critical crossroads where waste valorization is no longer optional. It is a core lever for decarbonization. We will explore how optimizing sinter plant processes can unlock sustainable revert recycling. Simultaneously, we must navigate the complex realities of iron ore availability, regulatory constraints, and the urgent need for advanced beneficiation. We will also examine the critical role of ferroalloys in producing specialty grades and how a formalized mineral exchange can revolutionize transparent price discovery. Joining me to unpack these issues is an esteemed panel of domain leaders from Tata Steel, JSW Steel, and Jindal Steel. Please join me in welcoming these dignitaries one by one onto the dais. First of all, I invite Mr. Dipankar Dasgupta, Executive in Charge, IBMD Tata Steel. While he joins us on the dais, I will read out his brief profile. He is in charge of Industrial Byproduct Management Division at Tata Steel, a dedicated profit center for solid waste and byproduct management having an annual turnover of $1.2 billion. This cuts across the entire value chain of the organization. The business drives value creation from waste based on 3R principles of circular economy and cementing sustainability leadership position of the organization through definitive initiatives. He has 30 plus years of experience in Tata Steel, having served in various business leadership positions. He has led various functions, including business planning, operations management, and optimization integrated supply chain, manufacturing, maintenance, raw materials, operations and maintenance, and continuous improvement through Tata quality management practices. Welcome, sir. Welcome to the session. Next, I would like to invite Mr. Rakesh Ambastha, Chief of Agglomerates, Tata Steel Limited. So while he joins us on the dais, briefly about him, Mr. Ambastha is a B.Tech in Mechanical Engineering from ITBHU. He has joined Tata Steel in 1990 as a graduate engineer trainee. He has spent 36 years in Tata Steel, acquired techno-managerial expertise as well as in-depth knowledge of operations and maintenance, project executions, and engineering in diversified areas in integrated steel plant across locations like Jamshedpur, Kalinganagar, and Port Talbot, UK. His areas of expertise include project execution in greenfield environment, commissioning and stabilizing operations and maintenance of sinter plant, pellet plant, power plant, engineering of iron ore beneficiation, and agglomeration. So welcome, sir. Welcome to the dais. Next, I would like to invite Mr. Mohit Ratolikar, VP Commercial, JSW Steel. Mr. Ratolikar has over 26 years of experience in senior management position across India's steel value chain. He specializes in driving operational excellence, strategic market development, and end-to-end commercial success. As BP Commercial at JSW Steel, he oversees procurement, sales, and complex supply chain operations. Welcome, sir. Welcome to the dais. Next, I would like to invite Mr. Rajat Khandelwal, Head Procurement, Ferroalloys and Metals. So, Mr. Khandelwal is an engineer from engineer in mining machinery from Indian School of Mines, Dhanbad. He began his career with Tata Steel in Equipment Maintenance Department of Noamundi Iron Ore Mines. He brings with him 19 years of rich and diverse experience in Tata Steel, where he had contributed in various strategic initiatives, and he has moved across various value chain, mines, steel works, and presently as procurement in bulk commodities, ferroalloys and metals. What I would like to highlight that he is a gold medalist from ISN, and he is a winner of prestigious Yule Medal by Mining Geological and Metallurgical Institute of India. So, welcome, Mr. Khandelwal. Next, I would like to invite, so just a second, please. Mr. Manish Singla Mr. Singla would be joining us shortly. I think he's on the way, right? So, Mr. Singla is on the way. The heavy rains has delayed his arrival. So, meanwhile, we will start the session. And first and foremost, I invite Mr. Rakesh Ambastha. He has got a presentation, so if the presentation is displayed. So over to you, sir.
ये बटन प्रेस कीजिएगा, ये लेजर का, ठीक है। नेक्स्ट स्लाइड को आपको इससे ऊपर वाले से करना, बड़े वाले से, और बैक इससे ग्रीन वाला यूज करिए, इस पर
First of all, I am thankful to M. Johnson for inviting me for this conference to share a case study related to sinter plant Kalinganagar, Tata Steel, where we have used revert material in its operation. This is the session number 7. I had been there in all the session. I have seen different topics being discussed, like steel and scrap outlook, Indian steel demand. Then you had also on the scrap recycling and generation, decarbonization, logistics. In one of the sessions, I may be wrong in my data, the crude steel production being indicated in financial year 26 is around 200 million ton. Now, India is in an interesting phase where crude steel addition is taking place. But from operational, there are different challenges. One is when you do a project, one of the big challenge is to execute and commission in a safe manner. After commissioning, how fast the ramp up can be done to take it to the rated capacity. Next challenge is, once you go to the rated capacity, how good you can sustain this performance, taking into account, one, increasing the productivity without compromising on quality, taking care of the environmental norms, and reducing cost. My presentation deals with this, how in sinter plant Kalinganagar, we have sustained the production including the waste that reduce the cost, taking care of the quality and also the environmental equipments. This is the abstract which I have already indicated. Now, this is the value chain of Tata Steel Kalinganagar. Now, in one of the presentation I was in the logistic, iron ore is being fed into the blast furnace. Actually, it is the fines which is converted to sinter and pellet which is being converted to the blast furnace. And in Kalinganagar, we have achieved 95% agglomerates in blast furnace, 51% pellet and 44% sinter. Now, by using this, the coke rate, one of the major enablers of reduction of coke rate in blast furnace is increase in agglomerate if the quality of sinter and pellet are maintained. Now, by increasing this agglomerate, the coke rate has reduced. Now, direct impact on tons of CO2. So, this is an important enabler in any steel industry to reduce CO2 emissions. We take targets, but we must know what are the enablers and how to achieve that. Now, in an integrated steel plant, you have waste generation. That is a norm. What are the types of generation which is indicated? LD sludge, this is from steel melting shop, mill sludge, mill scale, flue dust and ESP dust and many other. Now, if you see in an integrated steel plant of 6 to 8 million ton, around 50,000 tons of waste are being generated in the process plant, and the LD slag non-metallics I have indicated. These are general thumb rule. These are type of generation. Now, the real challenge in an integrated steel plant is how to consume this. First of all, our understanding should be very clear because waste need to be segregated in terms of what are the components in. Now, if you see in the LD sludge, there is 60% Fe. Now, there is a potential out here to substitute iron ore fines, which has got 62 to 63%. And iron ore fines, mind it, it is costly. If you see LD slag non-metallics, you have around CO percentage 50%. Now, this 50% is substituting costly limestone and other fluxes, another potential of cost reduction. But see in the components of PSW, there are components like carbon percentage, which is indicated in the BF flue dust, which is indicated in the ESP dust, where it is not good for process plant. Then you have also oil content, which is there in the mill scale, which is also not good for plant. So just to summarize the different elements in solid waste, desirable elements, undesirable elements, harmful elements. To summarize all these components, what they do, like I've already indicated, what is the role of Fe, what is the role of CO, silica and other thing. It is explained out in this slide. Now, in the role of a sinter plant in steel plant, apart from production and achieving the desired quality, it is one of the only major enabler to take waste. Now, once we are taking waste, we have to be very, very careful. That has already been indicated in my previous slide. You have got good elements in terms of Fe, in terms of CO, but you have also harmful element and undesirable. That is what is required in sinter plant, how you have to manage all this thing to get a good productivity, to get good sinter quality so that blast furnace can use, to maintain environmental norms and to reduce cost. Now, challenges in waste utilization. This because sometimes I have observed in sinter plant, people are using PSW and then complaining that we are losing environmental equipments. It is just because our understanding of the constituents are not there. If understanding is there, how to use that is most important thing. So first of all, the challenges. Environmental concern. In a sinter plant, you have electrostatic precipitator. This is an environmental equipment. If it get damaged, legal notice, you'll closed. So we must know what is that challenge. Challenge is oil content. We have to be very, very careful with the oil content which is coming to the process solid waste because it has got capability to damage some of the equipments of electrostatic precipitator. Productivity of sinter plant. Sinter plant actually is designed for -8 millimeter to 150 microns. But all this solid waste actually has got a lot of microfines. It affects the productivity of sinter plant. How to manage the productivity with increased usage of PSW will be explained in my subsequent slides. Now, sinter quality. Sinter quality has to be consistent, then only the blast furnace can use. Now, again, you have in the solid waste a lot of variation in terms of moisture, in terms of silica, in terms of alumina, in terms of CO. Now, if these variations are there, how are you going to homogenize to get a proper output to get the results? There are ill effects on blast furnace also. Like if the phosphorus content or zinc contents are higher in the PSW, it will impact blast furnace. So taking into account everything, we have the case study presents how we have tackled all this. Now, this is a photographic image because we need to be very careful when we are using waste. What are the ill effects? Okay, like when you are driving a car, you should be very clear with Indian roads. Some of the Indian roads are not good. You have got speed breakers, you have got this. So you have to be careful while you are driving. So similarly, when you are running a process plant, we have to be careful what are the ill effects. And the failures need to be understood. So this is one of the failure of a sinter plant where the collecting plates got bent and the reason was oil content in the process solid waste more than prescribed. Okay. So what strategy we adopted? In integrated steel plant, we have three important departments. One is the RMHS and logistics. Second is the raw material bedding and blending. And third is sinter plant. All three departments requires a good collaborations to get a final results. So first is the raw material handling department. All the reverts which are coming need to be segregated. We should have a very good analysis system which indicate what is the Fe content, what is the carbon content, what is the CO, and what is the moisture. And then you should have a blending constituents. Now I'm using the word waste. After the reverts are mixed, then we have coined a word, process solid waste. Now once a process solid waste has been made, that can be used. Now if you see, once the process solid waste has been made, there are certain important things need to be understood. What is the maximum oil content, what is the maximum alkali content, and what is the maximum phos content and carbon content. So all these four are written out there. So by a strategy of proper blending at RMHS, in Kalinganagar, we have controlled all this, and once the final mix has been made, it is transported to RMBB. Now RMBB, which is there in Tata Steel Kalinganagar, see, again, here we are using process solid waste, and this is just an input to all of you, is that any process plant, the flow chart should be very well understood. Because if you understand the flowchart properly, you should know what are the enablers, how to use that. Now, if you see in this particular flowchart, we have got a bending plant where we have taken advantage of the technology which is also there. So once we are running a plant, there are different technologies given by the OEMs. We should know. One of the technology given is a large pile size. We can go to a pile size of 80,000 tons. The higher the pile size, we can absorb. Then the way feeder seeder system should work properly, because when you are adding PSW, you are actually adding some FE, some CO. So if you see in this slide, we have crushing circuit which optimizes. We reduces it when we are using PSW so that the CO balance is there. Quality consistency, that is coming in. Again, coke crushing is taking place, but coke is also coming through PSW. Through the way feeder calibrations and other important enablers in RMBB, we control it. Now, this is a photograph of Kalinganagar sinter plant where the large pile size plays an important role to use more PSW. Now, coming back to after the RMBB has got the PSW, the term used is the base mix. Now, this base mix is supplied to sinter plant. Now, again in sinter plant, the process people should know how to use that. First of all, they have their own enablers. Are we using the enablers properly? Again, I'm coming to a car so that everybody is clear. In a car, we always talk about fuel efficiency. We always talk about external factors, petrol and other things. Have we ever talked about, are we tracking the uniform wear of the tires? If we are tracking the uniform wear of the tires, your efficiency will come down. So any process plant, people in the process should know what are the enablers you have got. So these are the enablers for the sinter plant which I have mentioned. So again, sinter plant Kalinganagar. This was established in 2014 with a 6 million plant. Now, in this initial design, we have taken some enablers which is given in the technology, like mixer and normalizers. We have got a good sinter machine. All these enablers were made ready and we used it properly when the PSW was used. In terms of proper bed filling, in terms of proper heat input, in terms of proper bed air flow through the waste gas fan. So these are the inputs on the how we have strengthened the bed filling system of the sinter plant, which allowed microfines in the PSW to be used. So this is again Kalinganagar sinter plant, sinter machine indicating a good bed profile. These are the results. Again, in my presentation, I'm giving more on the result rather than on the strategy, because we have got good results at Kalinganagar sinter plant. So now comes to final to the results. Now, if you see the financial year 25, we had process solid consumption of 0.29. Financial year 26, we have gone up to 0.43, that is 4,30,000. And in financial 27, Q1 is 0.14. Now, everybody through the newspaper and other reports are aware that in Kalinganagar, initially we had one blast furnace. It was 3 million, now we are at 8 million. And the BF2 has started in September. Ramp up was taking place. Sinter plant was designed for 6 million. We were operating as per blast furnace requirement. But come the day, the sinter plant team demonstrated increased production, increased uses of PSW. With increased steel production, more PSW has been increased, but sinter plant, without compromising on productivity and quality and environmental norms, has given results. And presently, we are at the rate of whatever waste are being generated at around 50,000 tons per month. We are consuming it. And we are also preparing it how to take it more. So this is the specific solid waste. Now, when we discuss about process solid waste, some plants will tell that we are using this much and this much. Never speak on isolation. You have to speak on also in front of what is the availability, what is the productivity, what are the environmental norms. So if you see the net productivity, again, since the requirement was not there in financial year 24 and 23, but once the blast furnace BF2 came, commission stabilized, the sinter requirement increased. And then the production increased, but we also increased PSW, but there was no increase in net productivity. As a matter of sinter plant 496 in India is a benchmark in terms of productivity, operating at 39 tons per square meter per day, that is 19,500, with PSW usage of 106 kg per ton of net sinter. And when you are using PSW, there are problems related to oil and carbon, your availability will come down. But if you see the results, no drop in availability. Sinter quality, one of the parameter of any process, you need to understand what is the quality. One of the important quality parameter of sinter is return fines. If your sinter is not being made properly, return fines will increase. But if you see the return fines, as a matter of fact, we have dropped the return fine through better process control, better bin management, and the results are there. Other quality parameters are also steady, like RDI, standard deviation of CO, and other norms, within norms. I have not given the cost because this cost is more company related. But if you see the kind of saving which we are making by using PSW, there is 46% in FE. We are in PSW, we have got 8% CO. Carbon is 12%. It is substituting iron ore fines, costly, limestone, which is a costly material, and coke breeze. These are, if you use 1,000 tons of PSW in a proper scientific manner, which was explained in the previous slide, you see the quantity saved in terms. The more we are using all these reverts, I have been observing one of the challenge logistics is facing in India is a lot of logistic challenges there. So internally, if we are using, we are also giving some easing out to the logistics team. However, the most important thing is related to the environmental equipment. Environmental equipment should not degrade with increase in PSW. With my experience already, Mr. Arnav told about my experience 36 years. So I have seen some of the problems in electrostatic precipitator while running sinter plant. In Kalinganagar, right from day one, we had a very, very strong operating and O&M discipline, and we have been able to maintain the health of the ESP. All the 10 fields are available. It is a two-pass design with a tumbling hammer. You need to understand how the secondary voltage and milliamps are developed. If these are being taken care of, your emission will be under control. Instead of going to results, you should be more interested what are the equipment and how are you taking care of that. So in conclusion, sinter plant in an integrated steel plant of BF route is an important department where recycle waste can be used. Now waste has to be used in a proper scientific manner, which we have coined a word known as process solid waste. That means it has got all the quality parameters which is required for sinter plant, and then you have. And lastly, if you have a well-executed strategy, results are there, which has been demonstrated. Thank you.
Thank you, Mr. Ambasta, and we are glad to know that with your innovative processes, there has been a 100% utilization of sinter waste, even though the production has been enhanced by almost 2 million tons. Productivity has been enhanced, quality has been enhanced, there has been savings in raw material cost, and the ESP health has been maintained. So thank you so much for these insights, and overall, with all these parameters, the processes have become more sustainable. So thank you so much, sir, for all these insights. And before I invite the next speaker, I would like to invite on the dais Mr. Manish Singla, who was caught up in traffic, and I would say had enjoyed extra few minutes of fresh Delhi air. So Mr. Singla is head Mineral Auction Jindal Steel Limited. He is a senior strategy and M&A professional with over 20 years of experience in metals, mining, coal gasification, power, steel, cement, ports, and related infrastructure. At Jindal Steel, he is leading mineral block acquisitions, strategic planning, policy review, pricing strategy, and M&A initiatives. Previously, we know he was working for CRISIL Consulting. So welcome, Mr. Singla, to the dais. Thank you for joining us. Now we move to the next panelist. I invite Mr. Dipankar Dasgupta, Executive in Charge, IBMD Tata Steel, to share his thoughts on the subject. Sir, please.
First of all, I realized that between me, or rather us, in the panel and the lunch, we stand between you and the lunch, especially on a cold, rainy Delhi morning. So that's unfair, and we are possibly a little bit short on time. So I realize that, and therefore I will restrict my presentation to much shorter times. Start with a big thank you to Vinay. Is incidentally, for all of you to know, there are 2 batchmates that I have, which means we are 3 collectively. Between me, Vinay and Rakesh, we are all 90 batch graduate trainees of Tata Steel, and Mohit is an ex-colleague of Tata Steel. So heavily represented, but not obviously any bias towards all the other panelists and colleagues. Thanks, Vinay, for calling me over for this fantastic annual event which Metal Junction does, the ISMC, which brings together a lot of young and not so young minds across the industry to talk about a very, very important subject. While I missed yesterday's session, but I had a brief glimpse through the write-up which Arunava had sent me, and today morning I witnessed some of the presentation, and there's a huge amount of energy and discussions and noise about steel. Obviously so, because it's a steel conference, and in India, why are we so concerned? Because all of you know the context of steel. We cannot but survive without steel. It is still one of the most affordable materials of choice for the industrialized world. And in India's context, obviously, it is one of the most important, I would say, element that will help the country grow from what it is today to the vision of our Prime Minister as an Atmanirbhar country. So a country like India cannot but do without steel. Therefore the conference, therefore all these discussions. But we also know another very big dichotomy about steel. And what is that? It is one of the most hard to abate sectors. So while nobody denies the fact that from the current 185, 190 million tons of steel, we are slated to grow in the near future. If you recall our Honorable PM's vision to 400 million tons, even if that does not happen and we reach somewhere around 300 to 350 million tons over the next 5 to 7 years, that's a huge strain on the overall ecosystem of the country from every aspect that you have been hearing since morning. So when Vinay and Amitava told me to talk in this session, I'll tell you briefly about what we do. The normal suggested topic was on scrap and scrap recycling. And I thought there are far too many speakers talking about that. And therefore I proposed something entirely different, which I feel as a country, as we grow, holds tremendous amount of importance. This is about 2 things. One is valorization and the other is decarbonization. As I said, most hard to abate sector, you have to grow, but at the same time, our country has also signed up to a net zero by 2045, and Tata Steel as a corporate has already adopted a policy on net zero by 2025 in carbon emissions. That's a huge ask. All of you who are in the industry, all of you are in the industry, you are aware that on 2 fronts mainly, on the technology front, on development of scalable alternatives, it's a big, big challenge. And therefore, this whole debate about the BF, BOF route versus the EAF route, and that of course also ties you up to another thing when you talk about EAF, which is on green energy. That's a subject for a separate discussion, but decarbonization for the steel industry and a country like ours becomes immensely important. The other thing, which we talk even lesser, is valorization. So what is valorization? I was just checking before I started, and I'll read it out from what our favorite companion talks about, which is Google, it says valorization refers to the process of assigning, preserving, and increasing the value of something. That is exactly what I represent for Tata Steel, and I'm sure my colleagues from the industry would be also having corresponding thoughts around this area. We actually are a 3R, 3R commercial wing of Tata Steel. So industrial byproduct management, IBMD as we call it, is a division which was conceived in 2013 in Tata Steel. We never existed before that, because the company realized that this is an area where there requires to be a focus. I'm happy to tell you that today, like Arunava mentioned in his opening comments, we are a $1.2 billion company. Almost 12,000 crores of business is what we are doing purely from slag valorization, and I told you what valorization is about. So it is not about making money. It is about making money in converting waste to sustainable, utilizable products. And that is the gamut of the whole session that I wanted to take you briefly on. Too large a subject to cover in such a short time, and therefore I will have just a few slides. Should you have any questions after that, I will be happy to take you through. You know, all of you know that every ton of steel that we make actually generates close to 2.2 million tons of waste, including gases. So that's not an easy thing to achieve. So while everybody talks about logistics challenges of how to bring scrap, iron ore, coal, how many people did you hear talk about logistics challenges of how do you transport slag? Where do you take the fly ash? What happens to the coal tar? So it sets you thinking, you know, this is a subject which is not only for the steel industry, it's a subject for we as individuals. I don't know how many times you wonder how many bags of trash goes out of your house every day. And what happens to that? You utilize the toothpaste, but you rarely think about what happens to the tube or the box that contains it after you have used it. We rarely give a thought to it. And when you think about the scale of the country, you'll realize where are we stepping on. So this is the context of the discussion. And it is not only important, as I would say, for steel, it is important for all the industries that operate today. And a term which is now very common in the boardrooms is called the social license to operate. As things get tighter and tighter, you will see that the social license to operate in any industry will become tighter. People become more responsive. Who spoke about, I think somebody else spoke about rains in Delhi and AQI coming down to 61. Any idea what is? So we have a plant, we have the advantage now of having plants in Europe. Any idea? There's a city called Aimuddin, very similar to a city like Jamshedpur. Small city, industrial city. What would be the AQI there? Any idea? Any guess? The AQI is about 10 there. And even as we speak, that's not the thing to clap about. I'll tell you why. Even as we speak, Tata Steel Netherlands is in huge trouble because the community has raised concerns of pollution and dust level to the extent that they have gone ahead and said that you can close down the plant. So our CEO MD says whatever is happening in Europe will happen in India in the next 4 years, 5 years. There's awareness in the people. There is a lot of social media, press coverage, and in general, the government restrictions which is going to come, which will force us to think how we, for every ton that you make of a valuable product, you'll be forced to think, what do I do with the rest of the things? And that is where this whole ecosystem comes. That's a brief I wanted to talk to you about. Some good news which I want to share about the tasks that we do. You know, possibly, I think that is the right data, possibly Tata Steel is the first company which has actually branded byproducts. So what you considered as waste, today we have got a branded product. So when you read these two words, Agrito and Nirman, these are branded products of LD slag, one of the most difficult materials to reuse or valorize. I am happy to report to you that between these two branded products in last 1 year, 1 million ton of natural aggregates was saved. A 1 million ton. You would have wiped out 2 or 3 small hills to create stone chips and sand. Tata Duraco is the next brand. This is a brand which comes out of blast furnace slag. You know, 0.4 million tons of green concrete. So you actually replace clinker. How does it impact carbonization? The first two. When you do this, you are reutilizing an industrial waste and preventing ecosystem damage by sand mining, by stone mining, or by clinker mining for the cement industry. 0.4 million tons of a value-added product called GGBS has replaced natural clinker in the construction world, largely in national highways and also in very marquee projects. I do not know how many of you have heard the Vrindavan, Chandrodaya Vrindavan Mandir in Mathura. It is one of the largest temples in the world which is being constructed by L&T to withstand the next 1,000 years. 50,000 of Tata Duraco is in the foundation of that. Incidentally, that foundation, because of that target which they had to meet, the foundation is bigger than Burj Khalifa. 50,000 tons of Tata Duraco is in that. Another product which we don't think of in steel is coal. While we think of coke, while we think of coal as a reducing agent for the blast furnaces, we don't often realize what happens to, as usual, the tailings, the rejects. So we have actually valorized 1.7 million tons of coal byproducts to power a 1,000 megawatt power plant for an entire year. This is without fresh mining of coal. And while we all talked about scrap, sourcing, buying, I do not know how many of you registered this. At least this is a number for Tata Steel. Last year, 2.5 million tons of scrap was added in the blast furnace to take our production to 22 million ton. Of that, 60% is the general average number. Jamshedpur actually recirculated 75% of scrap, which we internally recovered from materials like slag and internal generations of scrap. So that much less you bought, that much less you transported, and therefore while the slag had a direct carbon footprint reduction impact, you have also reduced scope 3 emissions because of that. So this, ladies and gentlemen, is a brief snapshot of what we do, what we have been doing, just presented to you to incite your thoughts as you go back to your industries and look at the various possibilities and opportunities that exist in this space. So these are the numbers for the 3 products I talked to you about. 5 lakh tons, 5.2 lakh tons of Tata Nirman. This is a product which is currently being also developed to actually replace sand. So you know how availability of sand is slowly going away, how mining is now restricted, and therefore this is a product of the future. Tata Agrito, of course, is what replaces what we typically know as Gitti. It's the coarse aggregates. Tata Agrito is 1.5 times stronger than Gitti in strength and in properties. This is a fully weathered material. And Tata Duraco, of course, is a value-added value-added product from blast furnace slag, as I explained to you. The second part of what I was talking about in the beginning is all about carbon. The global benchmark of carbon, as we know, as the targets which have been put up, is 1.8 to 1.9. Where is India? India's baseline is about 2.5, largely because, as I told you, there's the debate on EAF versus BOF continues, right? And also the debate about how India will gear up, even if we were to move into EAF, DRI route of steelmaking, how will the power sector emerge so that the power which is available to make this process green is also green. As long as you are using thermal power, it's actually hoodwinking. While you might feel happy that I have gone into a decarbonized process, the country does not benefit. And Tata Steel, as I told you, has taken a decarbonization target of 1.8 tons of CO2 or net zero by 2045. So, if you look at some of the key developments which are important, that is written at the bottom of the screen. Very, very important. All of you would have heard about CCTS, equivalent of CBAM in Europe. While CCTS, that block in between in red talks you about the current state of CCTS. It is currently on compliance. You might be aware that specific site-wise CCTS targets have already been given to the cement industry and to the steel industry, right? So as we speak next year, we will look at carbon trading starting. And I think Metal Junction and Vinay's team will play a big, big role in doing this or in kind of generating this mechanism better and better. And of course, as we go forward towards our 1.8, lower than 1.8 target, we will have to work out strategies on how we decarbonize. So, one thing I also wanted to share, not my area of work, but since I represent Tata Steel here, possibly one of the first few commercial, currently it is at a pilot scale, but a commercial carbon capture unit has been set up with the goal, when you saw that goal of less than 1.8, one of the goal is to scale this up to a 1 million ton plant, 1 million ton carbon capture plant by the year 2030. The other very, very interesting thing, again, not of my area of work, possibly Rakesh's area of work. Actually, this technology will take Rakesh out of his current job. This is a Hisarna technology, patented by Tata Steel and Rio Tinto. Tata Steel Netherlands has been working on it. And the first pilot plant, as we speak, is under construction in Jamshedpur. So this reduces your carbon footprint of the standard. What happens is here you don't need the sintering process and the coke process. It's a direct reduction on the blast furnace. And this actually reduces the footprint by about 20 to 30%. So this is the other emerging technology I wanted you all to know about. Of course, there are many other decarbonization strategies which are being developed at various levels of TRL maturity, technology readiness level maturity, things like chemical leaching, chemical absorption, physical absorption of carbon, membrane separation, and cryogenic separation. Very interesting, I do not know how many of you realized, I talked about converting LD slag to natural aggregates. I do not know how many of you realize or it has registered that LD slag is basically containing a lot of lime. And therefore, one of the most interesting product to sequester direct carbon. If you leave LD slag and you weather it through the block in blue that you see, enhanced rock weathering, it can absorb up to 25 to 28% of carbon. So, even as we speak, a very, very interesting development happening in Jamshedpur, where we have tied up with a partner, where we are looking at sequestering carbon as the other offshoot of valorizing valorizing LD slag. Very, very important. If this technology matures and if it gets commercially viable, it will become commercially viable, that I am sure of. This will be a great relief for the industry in general. Not only in India, it will be abroad. It's not being done at many places. Biochar is, of course, a strategic lever which Tata Steel is using. Many of you might be using. And green aggregates and cross-industry collaboration in terms of steel, power, and oil. Very, very, it's written only steel, power, and oil, and cement, I would add, for the steel industry. Very important subject. I will actually urge next year when they do ISMC to possibly devote a section around this, because it is an emerging area of work and young minds, intelligent minds need to work on these technologies for future sustenance of the industry. That's all I had to speak about. Sorry I took a little bit of time, a subject very passionate for me, but I think very, very important for the industry to focus upon. Thank you very much. Any questions we can take at the end, I think.
Thank you, sir. Thank you very much to share such success stories like Tata Aggregates, Tata Nirman, Tata Dureco, and one can go on and on using of coal tar to power plants. So it gives us a confidence that the steel raw material value chain will become sustainable, transparent, and resilient. So you are really creating wealth from waste. So while you talked about 8,000 crores worth of revenue, the other wealth which is coming up is helping the entire organization by reducing the carbon emission and in their journey to 1.8 tons of carbon dioxide per tons of steel. That's the key wealth. And I am sure with all these insights that you have shared and the successes you have shared, all of us over here would agree that it makes the wait for lunch worthwhile. And with these few words, I would like to invite Mr. Mohit Ratorikar, VP Commercial, JSW Steel, with a hope that he will also share similar stories in terms of sustainability from JSW. Over to you, sir.
So very good afternoon to all my friends on the dais, off the dais. Now, since yesterday, we were discussing about the growth story, India growth story. A lot of speakers told about India becoming the next destination for iron ore and steel. So there are certain challenges. Although iron ore availability in India is abundant, coal availability is abundant, but there are certain challenges. I tried to put all this data statistically so that everybody, when all of us go out, we have a clear picture about the iron ore scenario in India. I am an iron ore practitioner from last 15 years. I work with Tata Steel, SL Mining, MSPL, and now with JSW Steel. And exclusively, I have been looking after iron ore, pellets, and scrap. So this is one of the, what we call it, interest area for me. Next. So we'll start with standard disclaimer. These are my personal, okay. Standard disclaimer. This is based upon my interest and my own statistics. And my views here may not reflect the views of my organization. Tata Steel now is India's largest steel manufacturer. Now there are 6 bases on which we are developing our business. Basically sustainability, integrated steel manufacturing, diversified product portfolio, technological expertise, geographically diversified and strong. Other than India, we also have interest steel mills in overseas like US and Italy. Now this is about JSW Steel. If you see the steel plant locations, we have a 10 million ton steel plant in Dolvi. We have a 22 million ton steel plant in Bellary, which is called Vijayanagar. We have a 5 million ton steel plant in BPSL, which is now called JSW JFE Steel. We have a 1 million ton each steel plant at Salem as well as in Raigad. So shortly we will be coming up with a 30 million ton steel plant in Paradip. Already the work has started. So overall, as per the management guidelines, we want to surpass the target of producing 53 million ton of steel in next 5 years. So we could be the largest steel producer, and I hope the world will take, world has already taken a cognizance or the efforts which JSW is putting up. Now this is a very, very interesting slide, and actually it is a crux of the matter. Now we will see how the growth of steel and iron ore has started. If you see the first line, CAGR growth, pre-COVID era, 2000 to 2020. The steel in the world was growing at the rate of 4.1%. Primarily, it was contributed by the growth in steel industry at China. China was growing at 11.2% and India was growing at 6.8%. Now, post-COVID era, which is 20 to 25, if you see, the world steel has actually de-accelerated. There is a degrowth in the steel production, minus 0.4%. Why? Because China has come down by minus 2%, but India has grown by. So whatever loss is happening in China, India is trying to compensate that steel growth. If you look into the future growth projection, and these are very credible based upon the international statistics, future projections from 25 to 50, the world steel will grow at 1.6%, China will degrow at 0.5%, and primarily the growth of 1.6% in world steel will be contributed by India, which will go at 4.1%. So we must be proud that India will be the next growth engine for sustaining the steel production across the world. Now, growing iron ore demand and supply concern, this is a very relevant slide for our presentations, and I have enumerated. This is calendar year 25. India is producing around 288 million ton of iron ore. As we move into calendar year 30, we will be requiring 446 million ton of iron ore. And looking into our Viksit Bharat projections for calendar year 50, we will be requiring around 800 million ton of iron ore. So this is a 3 times growth which we will have to capture in next 25 years. And if you look into the EC quantity which is available, as of now, 533 million ton of EC is available with India, and India is producing only 300 million ton of iron ore. So there is a gap of around 235 million ton in production of iron ore. It's a big gap. Now we are talking about moving from 300 million to 800 million ton in next 25 years, and at present we are facing a gap of around 235 million ton. Now why this gap of 235 million ton? Basically, because as you know, after the enactment of MMDR in 2015, mines were auctioned. So 151 mines which were auctioned, only 40 to 45 mines have started commercial production. So almost more than 100 mines are not operating at all. So they are not producing. So that is contributing to this deficit of 235 million ton. Another thing is that because of the high premium which has went into auction, the mining companies are limiting the production only to the level of MDPA. There is an agreement with government which you enact when you acquire the mine, by which you tell the government that I will produce 80% of last 2 years production. I may not be producing up to the EC quantity. I will produce lower, but it will be 80% of last 2 years production from the same mine. So everybody is trying to produce at MDPA level rather than producing at the EC quantity. So there is again a deficit. By 2035, around 300 low-cost mines, including many captive mines of integrated steel companies, they will be going out of lease. So there will be again a deficit. So this projection of 235 has not captured it, but going ahead there could be further deficit of iron ore by 2030. So just I am trying to convey the gravity of the situation, the seriousness of the match. We have big ambitions, we have big dreams of making India a growth story. We are saying that although the world still is stable, production is stable and China is degrowing, India will take up that position, but these are the key challenges. Now the fourth key challenge is that many PSUs, public sector entities, SAIL, OMC, NMDC, they are also not producing up to their EC level. Actually, these companies, these are legacy mines. They can produce up to their EC quantity and ensure that sufficient supply is available for the steel industry at competitive prices. That is not happening. Now, the fifth point, which is also a very relevant point, is that the logistics challenges is forcing many mining companies and steel companies to operate at a suboptimal level. Now, all this is contributing to the gap of 235 million ton. A country which could have been producing 533 million ton of iron ore is today producing only 300 million ton of iron. So that is the gravity of the situation. Government is working on it. Actually, many, last at least 1.5 years, so many initiatives are undertaken by government to promote usage of low-grade iron ore, to start mining activity faster. Like recently they enacted a situation, if you start mine within 3 years, there is some rebate associated with the premium. So all these things government is trying to do, but factually that there is a deficit in iron ore. Now this is India-specific slide. FY26 today we are at 312 million ton. Now total supply, if we wanted to reach 617 million ton, PSU mines can contribute 60 million ton. That is the gap between their EC limit and actual production. Non-auction merchant mines can contribute to 55. Likewise, if you see these 5 attributes, if they are addressed properly, they will take us to 617 million tons. Still, by FY50, our target, which is around 800 million ton, there is a gap of 170 to 180 million ton. So it is no surprise that India has become an import-dependent country, and import become only option to address the grade issue as well as the quantity and quality issue in India. This is another concern which is, I said, is that high-grade ore in India is depleting. So if you see in FY11, 60% of the iron ore which was produced in India was high-grade. Now it is around 42%. Last year's statistics is indicating it was around 42%. Now below 58 Fe iron ore grew from 15% to 26%. Now the grade, overall iron ore grade is deteriorating across the world. Recently you might have noticed Platts also has downgraded its index from 62 to 61. So this will give rise to certain new technologies related to beneficiation. These are the key areas for policy support, which government already has notified. The industry is working, industry association is working, FIMI is working, ISA, Indian Steel Alliance is working with government, ASOCHAM is working. See, all the agencies are working with government, and government has been very receptive because government understands this issue. India is known for its quality of iron ore, India is known for its quality of coal. Coal may not be great, but availability at least is abundant. So if India is not producing world-class steel and not generating the employment or not creating that economy, then there is a key issue. So government has already understood the issue and trying to address it systematically. But still there is many things to be done. Now of late, on 30th of June, there has been a notification where government has notified mineral exchange. Now this is a very, very positive step in terms of bringing transparency to the prices of minerals. Now, what government is trying to, just brief one slide I have prepared, what government is trying to say here. Like, there is BSc, there is NSC, and there is a governing body, or we can say that overlooking body, which is called SEBI, which all comes under Ministry of Finance. Similarly, in case of iron ore, there will be Ministry of Mines, then there will be IBM, Indian Bureau of Mines, which will be the overlooking agency. Now, there will be registered exchanges like NSE and BSC, and there will be a set of buyers, impaneled buyers, who will buy iron ore. Now here one thing is very important to note, that this circular states that there will be physical delivery of iron ore. It is not talking about paper market, it is talking about actual transparent mechanism of transfer of material and money from one hand to another. Arm's length pricing, that is the key. So for companies like M Junction, it offers an opportunity to get into this new business. And I see going ahead, over last 10 years, we have seen many unorganized businesses are getting into organized. So this could be one of the, mineral exchange could be one of the initiative by government to organize the sector. So this is the slide related to mineral exchange. It describes the procedure. I will share the presentation for the interested parties. These are the basic enablers. 50 crore is the minimum net worth required. All these things, anybody can read it. We'll move to. Now, related to mining sector's push towards sustainability and digitalizations, already MSTC, M Junction, they are carrying out multiple auctions. So already e-auction has become a norm in the market. Going ahead, next 5-6 years, we will see mineral exchange also will become very dominant scenario in India. Digital trading ecosystem is also a reality in India now. And data-driven resource planning has also become very relevant. So mining sector, which was a very laggard sector or ignored sector just 15-20 years back, has suddenly got attention of the technology, e-commerce, and new technologies getting into mining, which is actually very welcome move. Going ahead, I think Indian companies will be in a position. I had been to Australia, I had been to Brazil to visit many companies which supply iron ore to us. And they use electric vehicles in their mining. Everything is, controlled through a control panel. You will not see, not more than 5-6 people across the field. So that type of mining activity could be possible in India, but obviously India has its own challenges in terms of creating employment and ensuring happier citizens. So thank you very much. Thank you for your kind attentions. I will take any questions. Thank you.
Thank you, sir. Thank you. So while JSW is on the way to becoming one of the largest steel producers across the world, but there are concerns expressed in terms of depleting grade of iron ore, dependency on import. But then we are happy to hear there are certain positive policy measures being taken by Government of India in terms of notification for setting up an Indian mineral exchange, with assured deliveries. And of course, sustainability in the mines, there are many measures which are talked about, which included usage of EV vehicles in mines. So thank you, sir, for all these insights. And next, I move to a raw material, which when I joined the steel industry almost 20-25 years ago, used to be referred as a minor raw material. But it has not remained minor, it has become a strategic raw material. So I invite Mr. Rajat Khandelwal to share his thoughts on ferroalloys procurement.
Yeah, good afternoon all. So as we are inching closer to lunch session, I'll try to keep my presentation very basic, fundamental, and mostly revolving around the ferroalloys industry and what are the growth drivers and how the future outlook looks like to be. So dignitaries, they have spoken about iron ore, iron making, obviously the various byproducts. And now I'm, moving one step ahead as far as the steel value chain is concerned, which is steel making. So we all know the role of ferroalloys in steel making. We all know that without ferroalloys, it is is not possible to, actually, it is not possible for steel to achieve the desired properties for which the steel is known to be. So what is ferroalloys? Just giving the context. So with iron as a carrier, so different alloy elements contribute, different chemical, physical properties to steel and enhancing their strength, the toughness, ductility, corrosion resistance, etc. So if we see the ferroalloys, we classify ferroalloys into groups basically. The broad classification one is bulk and the second is noble. So all types of manganese alloys, chrome alloys, like ferrosilicon and all, they actually come under the bulk ferroalloys. And the other elements, like critical elements, for example, niobium, titanium, vanadium, etc., they actually fall into noble ferroalloys. These elements are very important because, and very critical for, for the specialty steel and the high performance steels like advanced high steel strength, which is AHSS steels, and obviously the HSLA, which is high strength low alloy steels. So as far as Tata Steel is concerned, so we actually buy both type of ferroalloys, which is bulk and noble, just to meet our requirements of the steel manufacturing. Now, if we talk about the global ferroalloys industry, it is expected that the global ferroalloys industry will grow at a CAGR of, the global ferroalloys market will grow at a CAGR of almost 8% in next 8 to 10 years down the line. But at the same time, ferroalloys industry is also undergoing some kind of a structural shift, which in a metallurgical parlance, we also call it recrystallization. So basically, as of now, there are three forces which are actually slowly but fundamentally reshaping the entire ferroalloys industry. The first is decarbonization. Everyone has spoken about decarbonization. The only thing is that now the compliance to various environmental norms and emission controls actually now transition from a mere regulatory requirement to a competitive differentiator. The future competitiveness will not only depend on the cost efficiency, but also on the carbon efficiency. And as far as the Tata Steel is concerned, so Tata Steel always promotes the use of such low carbon products, the products which get processed from sustainable practices. Second, I think most of us must have read a very famous book, which is World is Flat by Thomas Friedman. And since then, we have come across various terminologies like lean management, just in time, etc. But now today, the era of, I'll say the just-in-time supply chain is slowly and steadily giving way to just-in-case supply chain. Today, in today's perspective, the question is not actually where can I source the material at the lowest cost, but the question, primarily is who I can rely on, especially when the market is uncertain, just to secure my supplies, that we have seen in recent Middle East wars and all. And the third thing is that India role is changing nowadays. So if we see FY26, the installed capacity of ferroalloy is almost to the tune of 5.5 million ton, and roughly the domestic consumption is around 1.5 to 2 million tons in India. Still, there's a gap which actually we are using for exports and all. But with this, there will be definitely a rising influence in the Asia Pacific leadership. But at the same time, there will be emerging opportunities, especially in the development of energy efficient and cleaner smelting technologies. At the same time, there is an opportunity of expansion of export-oriented manufacturing capabilities. So we all know that various FTAs, various economic cooperative agreements, they've been signed with various countries. But are we able to realize all those FTAs or EPAs? Is still to be, it's a question that we need to ponder on, because I was just yesterday only I was reading that there's a government, India is all set to review the SEPA agreement with Japan, because if you see the last 10 years, the trade deficit has grown to 3x times. So while the tariffs have not been there, but there are NTBs, which is non-tariff barriers, which are actually, overcoming, or we need to overcome it, or they are actually hindering the inroads of Indian manufacturers to these countries. So we should be in a position to meet the quality consistently, because there are stricter quality and sanitary standards internationally, and as a manufacturer, Indian manufacturer, they should be able to meet it. And also, we also know in these today critical times, the export is one of the savior, especially in the era of when we say the imported inflation, our currency depreciation, and the capital outflow, etc. So this will also give us some boost as far as the currency appreciation is concerned. The third opportunity I will say is the integration. Integration both ways, which is forward and backward. Backward, when we say backward, it means the integration with the captive power assets, integration with the mining assets, and forward definitely is integration with the steel value chain. Yeah. So, just a minute. Yeah. So definitely there's demand in the area of high-grade alloys in the advanced industries. That's why I've just now spoken the role of high-strength steel, which is AHSS and HSLA grade steels. So it is actually very exciting to watch how Indian industry actually prepares for the upcoming growth in the ferroalloys market, whether the industry is able to tap the opportunity it creates for next 5 to 10 years down the line. Yeah. So amidst all the challenges like fluctuation, the raw material prices, especially of the manganese ore and the chrome ore, the energy prices, as we all know, the ferroalloy industry is very energy intensive. It consumes a lot amount of power, and there's a there's a global competition. I mean, the competition from the global suppliers. They are offering the material at throwaway prices. The overall growth outlook remains to be very optimistic as the industrialization accelerates in India. But however, the adaptation to cleaner technologies, producing technologies, whether it's melting technologies, other technologies, and the emphasis on the value-add material, they remain actually the key to the progress of, I'll say, the global metallurgy and economic sustainable growth. And as far as our supply partners are concerned, yeah, so there's a transition from vendors. If we say in the overall landscape, there's a transition from mere calling them vendors to strategic partners. So the thing is there's the importance of choosing right supplier in the emerging context. So the quality and supply is concerned, so choosing the right ferroalloy supplier can make a significant difference in product quality, operational efficiency, and the long-term profitability. There are digital platforms, real-time tracking systems, data analytics. It provides greater visibility into the supply chains. And the suppliers who adopt modern technologies, they are better positioned to ensure efficiency and accuracy. So as a Tata Steel, we always propose securing a long-term partnership with our supplier partners. And for us, the quality matters, the product quality and consistency matters. It is not only the cost, but as I've just now spoken, it is the total value that the supplier is actually offering us as far as the life of the ferroalloys is concerned. Yeah, thank you all.
you, Mr. Khandelwal, for changing our thoughts from ferroalloy being a minor raw material to a critical and important raw material for steel making. So amongst the numerous initiatives, what is becoming imperative is 100% sustainable sourcing. Now we move to our last but not the least speaker, Mr. Manish Shingla. So from big round of applause for Mr. Singla, please.
Yeah, thank you. Thank you, M Junction, Vinayji, for inviting me. Good afternoon, everybody. So my topic is related to the recently developed the policy change which has happened in the mineral sector on the mineral exchange. The market is moving from the bilateral trading to the transparent bidding system, especially the mineral trading. So that is the topic. So I will give you the gist about the same, what are the current challenges in the market, how the mineral exchange will address the challenges, what are the pain points, and how the more things can be done to make it the right thing. Yeah, thank you. So why India need a mineral exchange? So one thing is that currently today, most of the minerals which are getting traded are either through bilateral trading or through the state government or PSU portal through an auction mechanism. And that is the two-way mechanism which is happening as of now. So the mineral exchange will we make the transparent price discovery, but this will be subject to the liquidity in the market. So mineral exchange will make fair access to all the buyers, either it's a small buyer, big company, or a small company. So it will make access of information, especially the availability of the mineral across all the states, across all the locations in a transparent manner. And currently the ASP, which is IBM price discovered ASP, that is happening based on the weighted average of all the sales happening in the state for a particular mineral. So once the liquidity will be there in the market for the minerals, and once the fair price discovery mechanism will start, then it is expected that this will replace the ASP mechanism, and a few of the mineral and metals, we are also dependent upon the LME prices, because IBM published the prices based on the LME prices, for which, since Indian market is quite big market for most of the consumption point of view, still we are dependent upon the LME indexes, which may or may not be correct approach to do the things, because we are paying the mineral price at a LME prices. So this will reduce the difference between the international prices as well as the domestic trader prices, because in India, quality as well as the logistic plays an important role in deriving the price discovery of any mineral. And there is already a successful experiment being done in the power exchanges as well as in the gas exchanges. So in power, PXIL, IEX, HPX are already operational. And in gas, IGX is already operational since last 4 or 5 years back. And there is always already a set precedent which is happening on the trading of commodity. So this will be replication of the mineral trading through a new exchange. And how the regulatory mechanism will look like. So as of now, the mineral exchange is IBM is the considered regulator for the mineral exchange as notified by the Ministry of Mine. So I will tell you what is the regulatory mechanism in the power sector. In power, CRC is the regulator, which is given power by the Electricity Act 2003. And CRC has made the power regulations of 2021, under which all the exchanges, IEX, PXL, HPXL are operational. Similarly, in the gas, PNGRB Act gives power to the PNGRB board for making the gas exchanges. And IGX is operational under the PNGRB board. And this is how the gas trading is happening. And this mineral exchange, the MMDR Act has already given power to Ministry of Mine to frame the rules of the mineral exchange, and the Ministry of Mine has already notified the rule on 30th of June 2026. And under this, the IBM will be issuing the regulations. And once the regulations are issued, all the exchange players, including maybe M Junction also, will develop the mineral exchange, will apply on a licensing mechanism, and maybe there will be one player, there may be two players, depending on the liquidity of the market. And then the market player will operate the mineral exchange by making bylaws and rules. So these are the key drivers to make any exchange as a successful. So one is this exchange will be successful if the quality issues which are currently there in the iron ore or limestone or maybe manganese, bauxite, if this will address the quality issue, then only it will be successful. The second biggest problem in India is on the commodity logistic and delivery. In coal, it is a very big issue. In mineral sector, because of commodity prices are high, so logistic prices are not so much important. But yes, on the iron ore side and limestone side, the logistic plays a very big role. And there are constraints in the market, especially iron ore transportation through trucks, because the time availability in many of the clusters of the iron ore in Odisha or other states, the time frame for transportation is only 8 to 10 hours. So that becomes a challenge, and if the exchange will not only become a price discovery mechanism, but will also address the logistic issue, then the exchange can definitely be successful. And the third part, currently, like I mentioned, IBM discovered prices as well as LME discovered prices are there, but this will give way to the India-specific benchmark prices, because if the mineral is getting traded and consumption is happening within the Chhattisgarh, then why I will be applying the price discovery which is happening at London Metal Exchange. The fourth issue is the liquidity. So as you know, most of the iron ore, almost 150 million ton is captive, and they are using out of 300 million ton, almost 150 million ton is getting consumed from the captive mines to the own plants only. And the liquidity in the market from the merchant sector is only 120 to 130 million ton, and which most of them is covered by NMDC and OMC, almost 70 to 80%. The real liquidity market, which is in the market, is only 30 to 40 million ton. And liquidity will be the key. So if the liquidity will improve, then definitely price discovery will be more transparent and more robust. And the last bullet is that IBM also need to have a power similar to CRC as well as PNGRB, because the formation of CRC and PNGRB are directly under the statutory power of the Act, which is given by the Parliament. But IBM as of now has been given power by the Ministry of Mines. So how the market size will derive? So currently in India, roughly around 1.7 lakh crore of value of mineral dispatch happened last year. So as compared to coal, it is still on the lower side. In coal, it is around 2.25 lakhs or 2.5 lakhs crore if I consider only domestic coal. If I consider the coking coal, imported coal, then it becomes around almost 3.5 lakh crore. As compared to this, India's mineral market is very, very less, roughly around 1.7 lakh crore, out of which 70% of the contribution is by the iron ore. And within the 70% contribution, almost 30 to 35% is contributed by the captive players. Out of that, rest of the 35% market, around 20 to 22% is captured by the OMC and NMDC. So the real liquidity in the market will be roughly around 40 to 50 million ton, which is the real price discovery which may happen. So I agree with Mohit ji on the iron ore demand supply scenario. By 2030, it is expected that the demand will be roughly around 500 million ton, but we will be able to produce only 450 million ton, and there will be a shortage of around 40 to 50 million ton. Similarly, on the limestone side, although from the cement grade limestone, the number wise it is 700 million ton, but on the value wise, the value will not be much contributor on the overall commodity prices. And similarly, on the domestic front, limestone is not an issue, But steel grade limestone, which is currently India imports a lot, almost 80 to 90% is imported by the steel players. Going forward, also the steel grade limestone will be imported in future. Bauxite, few of the mines which are expected to start in next 1 or 2 years, that will replace the imported requirement which is currently happening. And the volume of bauxite is roughly 24 to 30 million ton, and by 2030 it should go by 40 to 45 million ton. So volume wise, and most of the bauxite is traded by, sold by OMC as well as GMDC. So rest of the mines are mostly captive. So real price discovery in the bauxite market is also only 10 to 15%. Manganese, yes, around 70 to 80% of the manganese is produced by MOIL, that is the only PSU, and rest of the 20 to 30% is produced by the captive players. Other bulk mineral, as of now, most of the bulk mineral is being consumed by captive players. But yes, there is a big gap in the critical mineral market, because as of now, the critical mineral is not there in terms of production. By 2030, there will be a large production of critical mineral expected to be happen, and that is where the gap mineral exchange will fill, because the price discovery of critical mineral currently is based on the LME prices or the metal index prices which IBM publish. Once the consumption and industry will be there to consume that, the price discovery of that mineral producing in India and getting consumed in India will be real driver for the price discovery. So worldwide, there are mineral exchanges operational and successful, but most of the mineral exchanges in the world level, especially the London Metal Exchange, which is the biggest exchange in the world, then Shanghai Future Trading, then Singapore Exchange, MCX in India, as well as JFX. Most of them are working on a paper trading, that is futures and derivatives and options. The physical delivery of commodities is happening very in the small volume, only 10 to 15% of the volume. Same is happening in the coal. In the world level, coal being traded physically is only 5% as compared to 95% in the paper trading. In India, this is the difference between the coal exchange and mineral exchange as well as the world exchanges, because in India, the exchanges which are designed as of now as per the regulatory provisions, they are intended to be delivering the physical market. And the paper trading, the future option may be in the future once the physical delivery market will be happening and established and liquidity will be there. Yeah, that's all from my side on the mineral exchanges. Thank you.
Transparent mineral exchange. So while, exchanges, as we all know, are the most transparent and efficient means of discovering price. And of course, Mr. Singla, as rightly suggested, we need to find a solution to the grade and quality issue. And most importantly, all such exchanges should be backed up by delivery. So thank you, Mr. Singla, for your insights. Now we are in the lunch time, the last session of the day, but the room is still full. So thank you, ladies and gentlemen, for your patience. And we will take just one question. Now, who is going to be that lucky lady or the gentleman? So, Amit, you decide, and please hand over the mic.
Yeah, good afternoon, sir. Thanks for the wonderful presentation. Myself is Sarvajit from Tata Tubes. My question to the industry majors as well as to the senior management of the metal junction. My question is that we heard about different brands, how Tata Steel is doing in terms of the branding, the value-add products, what we are finding from this slag and all these things. But there are also non-metallic scraps which are basically generated every day in and day out. So if I say name something like the e-waste, which is coming in a bigger way, also in terms of the refractory bricks which we are using or in terms of the Indian scenario, the plastics which the industries are thinking of injecting in the blast furnaces or the coke ovens by using the polypropylene or the polyethylene component. So how MJ and the steel majors can collaborate to extract value from this part of the value chain? Because I think this shaping the steel to scrap, but my question is scrap to steel. So these are the waste which are getting generated. Is there any thought process in the coming days in how MJ can collaborate with all of us in the steel majors to create value for the Indian subcontinent?
So wonderful question, Dipankar sir.
Thanks, Sarvajit, for that question. Actually, it was a part of, I'll come to the one part of your question, which was a part of my presentation. I cut it off because of shortage of time, which is on e-waste. One reason I could not come to the conference yesterday because I had to visit a facility here in Bhiwadi